Hello, I hope I'm coming through okay. It seems we have no audience. Well, I don't blame you. I haven't been around for a while. But I'm just here to let you know that I'm alive and well. And I have a video to play for you. I have a few actually. Went through quite the ordeal about 3 Thursdays ago. I wasn't going to say anything, but I made a video with Andy explaining the whole thing and lost the video. I can't find it. So, I don't know, but it seems 3 Thursdays ago I had a little problem. I spun a leak in my carotid artery on my left side, my neck, my jugular vein. And it was coming out like water. It was blood. And I didn't quite know what to do. So my son jumped right into action. He called 911. So I was bleeding out pretty profusely. And I actually thought this was going to be the end. I didn't think that I didn't think I was going to make it. And, when the ER got here, I kept feeling all this hair in my mouth, And I said, I got this hair in my mouth. I said, don't touch it. That's blood clots. Your blood's trying to clot the hole. And I said, oh my God. But on the ride to the hospital, for about 5 minutes, it stopped, which was miraculous. I don't know what happened, but it just stopped. And then as soon as we got to the emergency room doors, it started again. And I mean, I must have bled a good 2.5, maybe 3 pints of blood. I don't know how many exactly, but it was a lot. And the next thing I know, I woke up 3 days later with this contraption on my face. I was intubated and I couldn't speak. I had my hands tied down, and I think they really thought they lost me because they had told my son I had passed, but my ribs are all busted up from them doing CPR on me. I mean, it was an ordeal. I've never been that scared in my life, but at the same time, I wasn't scared. I thought, well, if this is going to be it, I guess this is going to be it. There was nothing I'm going to be able to do about it. And, well, I got lucky. That's all I can say. The Lord was with me that day. And obviously, He's not finished with me. He's got something in mind for me, so I'm finally going to try to get back to work on a regular schedule. I know I talk funny, and I hope you can hear me. If you can hear me, let me know. Say, yes, I can hear you. Hello, Robert, and Sea of Colonels. Good to see you, buddy. I've been through a lot in this last year, no? But here I am. I'm still here. Good Lord willing. And I'm going to keep bringing it as long as I can. And our friend Shockwave was... I'm lucky enough to have him as a friend because he gave me some material that he said I could use. So I am putting together a video that's going to be very interesting. It's going to be on not only the physical side of Saturn theory, but also the spiritual side of it. because, there's a whole faction of Jews that, put that little cube on their forehead and they pray at the wall. Well, they're worshiping Saturn. Now tell me, how could they come up with all of this and still from a speck in the sky? I mean, they just can't. It's impossible. But we're going to get to that, because I'm building that video. God willing, I'll be able to get it done. And now here you come. You're starting to come in. And thank you for everybody who comes to see the videos. It's good? Oh, good. Yes. And we'll talk some more. I'm just going to get to this video by Rick and his friends. And let me know. Wait a second here. I gotta find it. It should be right there. Don't give me no problems now. There it is. Okay. All right. Here we go. It's It's a little under 2 hours long. Okay. So I hope you enjoy it. And I'll be back to check in. Plus, I'll be on my phone. Okay. Here we go.
He's going to talk about the electric universe and Birkeland currents and other. I forgot your description of your presentation. So if you could start, that would be fine. Welcome to. It's a long-awaited discussion about the electric universe. So I think I gave you permission to present, so you can select your presentation and proceed.
Alrighty then. Let me select my screen here.
A talking star.
Yeah, okay.
Okay. How's that?
We see a bunch of stuff. We see a bunch of stuff.
YouTube.
There we go.
Wow, Starship Enterprise.
Do you see the
maximize that?
Yes.
It is maximized. I can't get rid of that bar on the left because that's how I have to navigate. If I try and go into slide mode, it screws everything up on my end. I can't see anything.
All right.
Well, in slide mode, have you tried just using the arrow keys to navigate?
Yeah, the arrow keys work.
Let me see.
This will work. I've seen him practice. It'll work.
All right. Well, let's not make it too complicated. I think we're ready to go. The electric universe, how we think the universe runs. By that, I think you mean how you and people who adopt this approach believe the universe runs. Is that correct?
Exactly. I'll go through a bunch of individuals that contributed over the years to show how the electric current flows through the universe.
So that's the primary postulate, if you will, or assumption.
Yes, that the cosmic web is basically electric current, and it's flowing in both directions and in all directions.
I notice you say the electric
I think it's best, if I may, I think it's best if we let Rick take the floor here. I think many questions will be answered / need to be asked later on, for sure.
Okay. All right. Well, I'll take the floor. Here's the overview. Christian Birkeland, he was the discoverer of Birkeland currents. He postulated that there were currents coming in from the north and south poles. His Torella experiments show that the electric discharges were going on to cause the auroras. He made an Arctic trip to observe the auroras firsthand, the electric discharge that they were carrying on a larger scale.
Could you
NASA
explain
calls
what
them,
a Torella?
Is the sound okay? Okay, a couple people wrote sound. Is it all right now, or do I need to turn it up? Waiting for a response. Let me know. I'll turn it back on, but let me know and I'll see it.
Torella is?
I will show you a picture of it right here.
It's a model of the Earth.
It's a vacuum chamber, and a magnified or a magnetized model, a globe inside the inside the vacuum chamber. All right. NASA calls them by another name. They actually call them by flux ropes or magnetic flux ropes in space. We'll go into Hannes Alfvén. He discovered Alfvén waves. He won the Nobel Prize for magnetohydrodynamics, and later he worked on his galactic circuit, which was ignored by everybody. And we'll go into Ralph E. Jurgens just slightly. He furthered the theory of an electric sun that was postulated by a fellow back in the 40s, I think. And we'll go into Donald Scott. He's professor of that was postulated by a fellow back in the 40s, I think. And we'll go into Donald Scott. He's professor of electrical engineering. He helped with the electric sun model and did a lot of the math. And he built the Birkeland current model that's currently available. I'll show you that as well, or you'll see that. And then Winston Bostick, he dealt with plasmoids. He discovered plasmoids, plasma focus device, and plasma vortex phenomena. He simulated cosmological astrophysics in his laboratory with plasma experiments, as well as Anthony Peratt later on after Bostick. And Willard Harris Bennett is responsible for the Bennett or Z-pinch. Invented radio frequency mass spectrometry, conducted research into plasma physics, astrophysics, geophysics, surface physics, and physical chemistry. I'm going to mention here and now that we think that electric discharge is scalable from the micro to the macro. Behavior electric discharge is scalable, basically. Electric discharge machining on the micro scale, thunderbolts on the Earth scale, and planets, moons on the solar scale, because they're created in Z-pinches, and stars aligned along filaments are created in these Z-pinches.
Okay, Rick, before you move on, could you go back to the previous slide? Are all these people deceased, or are there any who are still active and alive? I know Birkeland isn't, and Alvin probably not. What about?
I'm pretty sure they're all gone.
Okay.
I'm pretty sure they're all left us.
Okay.
Christian Birkeland, he died early 1900, and Alfvén, he died in 70s, and Jurgens, I think he died early 80s or something like that. And
you said Scott was a professor of electrical engineering. Just curious, what institution?
I'll be going through that. Don't worry.
Okay.
Christian Birkeland, his theories of atmospheric electric currents that elucidated the nature of the aurora borealis north and south. He invented electromagnetic cannon, basically a rail gun, and the Birkeland-eyed process for fixing nitrogen from the air. His theory in which energetic electrons were ejected from the sunspots on the solar surface and directed directly to the Earth and guided to the Earth's polar regions by the geomagnetic field where they produce the visible aurora. The proof came in 1967. The crucial results were obtained in 63, carrying a magnetometer above the ionosphere. He was nominated for the Nobel Prize 7 times. He was a smart dude.
But he didn't get it, is that correct?
That's correct. His experiments show how the rings of Saturn are produced, also how planetary aurora are produced. The Birkeland currents became the source of controversy, continued over half a century, because their existence could not be confirmed by ground-based measurements alone. His theory was disputed, ridiculed at the time as a fringe theory. You guys understand that, by mainstream scientists. It seems to be a natural consequence of our point of view to assume that the whole of space is filled with electrons and flying electric ions of all kinds. We have assumed that each stellar system in evolution throws off electric corpuscles into space, that it does not seem unreasonable, therefore, to think that the greater part of the material masses in the universe is found not in the solar systems or nebulae, but in empty space. He's saying that the missing mass, a good portion of this dark matter, is ions and electrons in space, in everywhere, basically. Electrons moving along a Birkeland current may be accelerated by a plasma double layer. If the resulting electrons approach relativistic velocities, i.e. the speed of light, they may subsequently produce a Bennett pinch, which in a magnetic field will spiral and emit synchrotron radiation. That includes radio optical, i.e. light, X-rays, and gamma. In 2007, the Themis satellite found evidence of a magnetic rope connecting the Earth's upper atmosphere directly to the sun. That's the Birkeland current direct connection that we have, and that Saturn and Jupiter and all the planets share with the sun. Everything that is in the solar system, even comets, are directly connected via a Birkeland current. As soon as they enter into the influence of the sun, they connect. The sun would give rise, where was I?
Oh, sorry, I thought you disappeared.
Earth's upper atmosphere directly to the sun. Apparently consistent with Christian Birkeland's theory of the aurora. That current of electric corpuscles from the sun would give rise to precipitation upon the Earth. And there's his expedition paper.
By precipitation, I'm thinking means electrons. Is that correct?
Ions and electrons are both coming in.
Okay.
The corpuscles are basically a Birkeland current. He didn't have a name for them, and they weren't called Birkeland currents in his time. He called them corpuscles. And here's Christian Birkeland here with the electrical devices. Here's the aurora on Jupiter. And this is Christian Birkeland. And here's a model in his lab, in his Torella, of Saturn's rings. He's explained how Saturn generates its rings. And here's this same experiment on the bottom picture. This is a diagram of the forces between two Birkeland currents. And here's how they Z-pinch. And in the center here, you would get a sun on a smaller Birkeland current and a galaxy on a larger Birkeland current. Okay? We'll move on to Winston Bostick. In 1956, Bostick demonstrated the existence of plasmoids, force-free charge-carrying strings, possibly mini Birkeland currents, plasma focus device, plasma gun, basically, the device that shoots electrons out one end. I'm sure you're well familiar with that device. 10 years later, he postulated an electron composed of helical plasmoids forming vortex loops around a ring, similar to Parsons' magneton. Bostick maintained that in his model, that this model could account for the atomic structure, strong and weak forces within the nucleus, and that it was a physical basis for string theory. But this view received no support from the mainstream scientific community and is considered fringe science. Here is a picture of plasmoids in the laboratory. Tony Peratt did this work, high energy plasma. Here is a picture of the North Pole of Saturn, or sorry, Jupiter. Yeah, there's a huge similarity there, and pattern recognition is part of the electric universe's toolbox. Patterns show up on all different scales. This is the one on the right here is in a laboratory, and you know what scale Jupiter is. So this is Bostick's work. He put 8 plasma guns and created little galaxies in the laboratory.
Huh. Spiral galaxies.
Spiral galaxies, yeah. And now we're into Hannes Alfvén. In 1934, he taught physics at 2 universities, one being the Nobel Institute for Physics in Stockholm, and in 1940 he became professor of the Royal Institute of Technology in Stockholm. In 1945, his title was changed to Chair of Plasma Physics in 1963, the year of my birth. Alfvén waves are named in his honor, and Alfvén wave is a type of plasma wave in which ions oscillate in response to restoring force provided by an effective tension on the magnetic field lines. He was the Swedish electrical engineer, plasma physicist, and winner of the 1970 Nobel Prize in Physics for his work on magnetohydrodynamics. That's repeating, sorry. MDH, it's called. In his acceptance speech, he warned all of us not to use MDH as it was too simple of an explanation for what was going on in plasma. Theories describing behavior of the aurora, continuing Birkeland's work, and the Van Allen belt, radiation belts, the effect of magnetic storms on Earth's magnetic field, the terrestrial magnetosphere, and the dynamics of plasma in the Milky Way galaxy. Let me get this sorted out here before I move on. And Willard Harrison Bennett, he is responsible for the Z-pinch, Bennett pinch. He conducted research into plasma physics, astrophysics, geophysics, surface physics, and physical chemistry. Another smart fella. The Bennett pinch is named after him. He invented radio frequency mass spectrometry in 1955. Bennett's experimental tube called the stormatron predicted and modeled the Van Allen belt radiation belts surrounding the Earth 6 years before they were discovered by satellite. It also reproduced intricate impact patterns found on Earth's surface, which explained many features of the polar aurora. Have you noticed that the theories of many things that have been discovered by probes have come to pass with an electric model, with modeling it through electricity? That's key to understanding that the electric universe does have merit in cosmology, I think, in my view. Now, this is Hannes Alfvén's circuitry. We have the galactic circuit, which is not much more different than the solar circuit. In fact, they're identical. Up here and down here is where double layers are set up and accelerate ions and electrons down into the galactic, into the galaxies. Same with the sun. We've got current leaving this direction, going around. This is the heliopause, by the way, and then the current's coming back into the equatorial plane. Don't get that confused with the solar wind going out. It's a two-way circuit, basically. And this is Hannes Alfvén's waves, Alfvén wave a package, a description of it, just basic understanding. Ralphie Jurgens, he brought the model of the electric sun to a really, really good place in the electric universe, and then Don Scott refined it even more. He had made some mistakes, but everybody does. Here's his papers, and here's where they can be found on https www.chronos-press.com/Jurgens/. And Don Scott, he has a book called The Electric Sky. He put it out in 2006. It broke new ground for the electric universe theory, explaining the flow of plasmas in the solar system without resorting to magnetic field reconnection found in conventional literature, which is stupid. Magnetic reconnection. Yeah. Scott has a bachelor's and master's degree in electrical engineering. He proposed that the stability of the sun or any other star arises from a controlled feedback in the corona, similar to the operation of an electronic transistor. He earned a doctorate in electrical engineering and was a professor of electrical engineering at the University of Massachusetts, Amherst. That's your question, the answer to your question there.
Thank you.
He's done a lot of math for the Birkeland currents and the sun models. As well as Christian Birkeland, he's done a lot of the math for his Birkeland currents, and I can show you that as well. The conclusion: yes, some of the math has to still be worked out, but a lot of it is already in place, such as Markland convection and flux tubes, Birkeland currents, and other math known figures of the different models of electric discharge. Some of these maths need to be adjusted for more complexity within the systems. A lot of the papers for the that we've in the electric, not me, but in the people in the electric universe have put out, can be found on the IEEE website. I'm sure Harry knows about the IEEE. NASA gives good data, but interprets it wrong, like dirty snowballs. Comets that, from observations of probes we sent, we see that they're rock, they're stone, they have sand dunes, they have cliffs, they're stone. They're basically stone being etched away. Wallace Thornhill said, all we need to do is add the electric force and think in terms of what electricity does, and add it to the current model of a gravity-centered universe model, which would widen and give us a better understanding of what's going on in the universe. Electric currents and discharge are scalable. Mainstream won't agree with that, and they haven't agreed with it for a long time, 50 years now. That's the end of the reading portion. I have a couple of videos here.
Okay, I'd like to go back a bit. Go back to this. Go back to the slide where you showed the galaxy. Now, go down from there.
Oh, this one here. How do cell phones work?
Okay, so on the left, you have a radio galaxy there. That's a picture of a radio galaxy.
I think so. Yeah. Well, that's the radio.
That's the radio picture of a galaxy.
Yeah, exactly. It's not visible light. It's radio. Yeah.
It's a radio map, and the galaxy itself is in the center between the two lobes.
In that little strip. Yeah.
Okay, so this model that you had, I didn't really appreciate this when you were first talking about it, and then I realized that you were talking about a radio galaxy. And
well, that's the only way we can detect these double layers is through radio, right? We can't really see them through optical because they're in dark mode.
Can you define double layer? What is that?
Are you familiar with Crux tubes?
No.
Oh, okay. Well, Crux tubes are a laboratory device that creates plasma layers, and what it does is it prevents ions from rushing. It stops the flow of ions in this area here, and electrons shoot right straight into the galaxy or sun from the poles. Electrons just, because they're negative and the sun is positive, they just shoot right into the sun, and that's the energy provided to allow the sun to do what it does. That's how it gets its power. It's not an atomic reaction from the core of the sun outward, because we see that the the interior is cooler of the sun than the exterior of the sun. So, sorry, go ahead,
Rick. How does electrons rushing toward the sun exclude that there's maybe nuclear reactions within the sun? How does that exclude?
We say that the nuclear reactions are occurring on the surface of the sun and in the chromosphere of the sun. That's where all the fission
always gets me to the people who think there's a 20 million degree core in the sun, and the surface is only 6,000. And they can't explain that. And, the corona is up there too, way up there. So it gets hot, and it gets cold, and it gets hot again. But here's the real kicker. If you were to go up in the stratosphere, it's freezing cold up there. So in essence, if the sun was like a wood-burning stove, it would be hotter, not colder. It's below zero. In fact, planes that fly over 18,000 feet have to wear oxygen. There's very little oxygen above 18,000 feet. That's all I wanted to say.
And fusion is going on. It's not happening within the sun because the sun is just basically a plasma sheath around a body that's in space.
If
A really, really large body. Go ahead.
Sorry to interject there. Just from my perspective after my interaction with the electric universe people, right, and my own perspective on this stuff from the atomic perspective, the function of the sun, in essence, is not clear at all. What I'm trying to say is all of the above could be happening, meaning fusion, fission, at the corona level, meaning the outer edges, right, or fusion within the inner realm. All these things are totally possible because the sun is actually quite mysterious still. Although the model explained here, the electric sun model, at least offers quite a bit of good detail there. And if you follow that one, then the most logical explanation would be, fusion fission processes at the corona photosphere level, if you will. But nothing is certain here.
Yeah, we haven't put any probes into the coronasphere and the photosphere, so I don't think we'll be doing that anytime soon.
The surface temperature exceeds that in the center. I thought you said it was the other way around. I thought you said the central.
No, the center is cooler.
That's right. Yes, I thought you said.
Yeah, well, you look at a sunspot, and that black area in the sunspot is hundreds and hundreds and hundreds and hundreds of miles down from the tufts, the photosphere tufts that we see. Down in there, they've measured the temperature, and it's around 3,500 Kelvin. The phototufts are around 6,000 Kelvin. The chromosphere is around 2 million degrees, and the corona is about 10 to 12 million degrees. The only thing that can explain that is an electric discharge process. The only thing that can explain that's contrary to thermodynamics, and that's one of the problems with the internal nuclear model of the sun. There's many more inconsistencies in their model that this electric model fixes. It fixes most of those problems. Anyways, any more questions?
For everybody, if anybody is interested in the workings of the electric sun model, I don't think all the details are given here. That's impossible within this presentation, of course. But Donald Scott has presentations out there on the Vanderbilt's channel, for example, where he explains the whole logic and the detail behind what Rick is saying here. And it is actually quite fascinating and intriguing, and jives with the observations, like accelerating solar wind only for about 10 to 20 solar radii at the maximum. And these are explained through electric phenomenon. So, they are very strong arguments, if you will. Yeah, Donald Scott, really good work.
Yep. Okay, so I'm going to play this video, just a portion
we
of it
only
here.
have like seven minutes and some. Is it less than 7 minutes?
No, it's 12 minutes, but I'll just start playing it anyway, and I'll stop it when we reconnect, and then I'll just keep playing it. And this is from See the Pattern, by the way.
Play a significant.
Can you all hear it well?
The origin of this concept comes from the plasma work conducted in the 1950s onwards, which revealed many surprises in terms of how plasma behave and showed many similarities to cosmological phenomena. One important aspect of the plasma cosmology is the idea of starting from the observed present state and trying to extrapolate backwards in time to an even more ancient time.
Oh my God.
Got hit by a commercial.
So from this, the first important point is that plasma cosmology rejects the idea of the Big Bang. The universe is not expanding and did not form from the Big Bang. Now at this stage, there are no clear concepts about how it formed, but going back to the point about working backwards, this would be an end goal, but in order to try and understand this, you would have to work outwards from what we can observe. And this is exactly what they focused on. Plasma cosmology holds that the basic laws of plasma physics that can be observed in the laboratory and in the magnetosphere, as well as the heliospheric plasma, also apply to interstellar and intergalactic plasmas. Space is filled with a network of currents which transfer energy and momentum over vast distances. These currents often pinch the filamentary or surface currents. The latter of these will give rise to a cellular structure in both interstellar and intergalactic space. In order to understand the phenomena in certain regions, it is necessary to map not only the magnetic, but most importantly the electric field and the electric current. A number of plasma phenomena like double layers, Birkeland currents, critical velocity, the pinch effect, and the properties of electric circuits are vitally important to understand cosmological phenomena. Our concept of cosmic plasma has changed considerably. Essentially, differences between the old and new paradigms include the following. Electric double layers are known to accelerate charged particles to kilovolt energies in the terrestrial magnetosphere. The necessity of a global electric current description to describe the transfer of energy in the magnetized cosmic plasmas, and this leads to the requirement of drawing the circuits in which the currents flow. This approach also emphasizes the discrete particle description in simulating cosmic phenomena, where particle currents may be explicitly followed. In the magnetospheres, plasmas exist in both active and passive states. This is probably true for all cosmic plasmas. Cosmic plasmas are often not homogeneous, instead exhibit filamentary structures which are likely to be associated with currents parallel to the magnetic field. In the magnetosphere, there are thin, stable current layers which separate regions of different magnetization, density, and temperature. In the case where a current flows in a partially ionized plasma, a chemical separation may take place. Due to this and other effects, space plasmas have a general tendency to be separated into regions of different chemical compositions. The similarity of the measured radio spectra from cosmic sources and that of dense plasma focus and other pulse power laboratory devices leads to the idea that plasma physics can be used to account for these phenomena. An electromotive force which gives rise to electrical currents in a conducting media is produced whenever this current flows perpendicular to the magnetic field lines. Folthammer gives a very nice explanation of why they are of great importance. A reason why Birkeland currents are particularly interesting is that in the plasma forced to carry them, they cause a number of plasma physical processes to occur. These include waves, instabilities, and fine structure formations. These in turn lead to the consequences such as acceleration of charged particles, both positive and negative, and elemental separation. Both of these classes of phenomena should have a general astrophysical interest far beyond that of understanding the space environment in our own Earth. In the laboratory, filamentary structures are a common morphology exhibited by energetic plasmas. In dense plasma focus machines, we often see a filamentary magnetic rope-like structure. High-resolution etchings of electron beams onto witness plates show nearly identical vortex profiles ranging from a dimension of a few micrometers in the dense plasma focus and a few centimeters in cathode electron beams. The size variation of nearly 4 orders of magnitude is extended to nearly 9 orders when auroral vortex recordings are directly compared to the laboratory data. When we examine the magnitude of the current in these filaments, fine detailed resolution of the current filament shows indistinguishable vortex patterns over nearly 12 orders of magnitude.
Scalability.
While source resolutions show that the phenomena probably transcends at least 14 orders of magnitude, from microamps to multi-mega amp electron beams. As far as we know, most cosmic low-density plasma also depict filamentary structures. As an example, we find filamentary structures in the following cosmic plasmas, all of which are associated with or are likely associated with electric currents. In the aurora, filaments are often observed forming parallel to the magnetic field. These have dimensions down to about 100 meters. Inverted voltage events and the in situ measurements of strong electric fields in the magnetosphere demonstrate the existence of filamentary structures. These would carry a current between 10 to the power of 5 and 10 to the power of 6 amps and span a distance of 10 to the 8 meters. In the ionosphere of Venus, flux rods are observed who are typically about 20 kilometers or 2 times 10 to the power of 4 meters. In the Sun, prominences, spicules, coronal streamers, polar plumes all show filamentary structure. Prominences are thought to carry a current of around 10 to the power of 11 amps. Cometary tails often have a pronounced filamentary structure. In the interstellar medium and in interstellar clouds, there is an abundance of filamentary structures.
That, my friends, you're looking at lightning in space.
In the center of the galaxy, there are twisting plasma filaments, apparently held together by a magnetic field possessing both azimuthal and poloidal components. These extend for nearly 500 light years, so 5 times 10 to the 18 meters. Within the radio lobes of double galaxies, where filament lengths may exceed 20 kiloparsecs, or 6 times 10 to the power of 20 meters. The formation of double layers within Birkeland currents. In magnetized non-homogeneous astrophysical plasma, a number of mechanisms are present that can generate field-aligned electric fields. These include anomalous resistivity,
Well, that was abrupt. Welcome back.
Well, I paused it really quickly, so we shouldn't lose anything. Again. Okay. We drop this down.
Hey, it's nice to see you, Rick.
Oh,
Yeah.
I don't know why it didn't show me in the first one, but anyhow. Okay, here we go.
We saw a star at the top of a peak.
That was Saturn in our ancient history, as at some point. It's too much. It's too heavy right now. Okay, here we go.
collisionless thermoelectric effects due to the energy-dependent wave-particle interactions, magnetic mirror effects involving trapped particles and magnetic field gradients, and electric double layers leading to localized charge separation. All of these have been studied in the laboratory and simulated by computer. It is the last mechanism that has been found to be remarkably prolific in producing appreciable potential drops in neutral plasma. These double layers seem to be strongly associated with Birkeland currents. Both experimental and computer simulations have shown the formation of a series of double layers along with current-carrying plasma columns or filaments. When double layers form in adjacent...
So you can see these particles are going... these are electrons and these are ions. This is what the double layer does. to these particles.
Current filaments, field-aligned electric fields are generated, which then serve to accelerate electrons within these regions. Peratt, in his paper on the evolution of...
I should point out that is a very simplified representation of a Birkeland current. You'll see Don Scott's model shortly.
Of the plasma universe, wanted to extend the study of cosmic plasmas to the case of the galactic dimension, so 50 kiloparsecs in width, by means of three-dimensional, fully electromagnetic and relativistic particle in-cell simulations. The simulation model consists of modeling a magnetic field-aligned neutral plasma filament in the presence of a field-aligned electric field. To study the evolution of the interacting filaments, a second filament was placed adjacent to the first one. He investigated as many as 6 filament interactions. Due to the 1/r force between the filaments, it appeared that a majority of the cosmic plasma phenomena are the result of 2 or at most 3 interactions among the closest filaments.
No, I hate these.
He's just left.
Sorry, fellas.
Up your home game with Leon's.
Switch to the RBC Avion
Sorry.
and get up to 55,000.
Some of us love commercials.
Okay.
Synchrotron radiation
I'm kidding.
of Bennett pinched filaments. One of the most important processes that limit energies attainable in particle accelerators is the radiative losses by electrons accelerated by the magnetic field by a betatron or synchrotron. This mechanism was first brought to the attention of astronomers by Alfvén and Herlofsson, which at the time was a remarkable suggestion, as plasma, magnetic field, and laboratory physics were thought to have little, if anything, to do with a cosmos filled with islands of universes or galaxies. Synchrotron radiation is characterized by a generation of frequencies appreciably higher than the cyclotron frequency electrons, continuous spectra whose intensity decreases with a frequency beyond a critical frequency, increasing beam directivity and strongly polarized electromagnetic wave vectors. The discovery of this mechanism has made it possible to infer that high-energy particles exist in many types of astronomical objects, and has provided evidence of extensive magnetic fields, and most importantly, it has shown that enormous amounts of energy may indeed be generated, stored, and released in cosmic plasma. Charged particle beams held together or pinched by their self-magnetic field have been of general interest since their earliest investigations by Bennett. The macroscopic picture of such a beam is that of a self-consistent magnetic confinement or compression against the expansion due to thermal pressure. On a microscopic scale, the individual particle orbits include radial oscillations due to the Lorentz force superimposed on the drift in the direction of mean flow. These are the betatron oscillations. Since they imply particle acceleration, there is electromagnetic radiation associated with them. Because the force is a V cross B force, the radiation from the relativistic electrons is synchrotron radiation. In the laboratory experiments, the morphology of the radiating plasma is both helical and filamentary. This shape only occurs when there are 2 wires which interact electromagnetically. This means initially the 2 columns will be attracted to each other. In computer simulations of 2 filaments interacting, it was found that whenever the attractive force between columns caused their separation to be reduced to a distance such that the repulsive force starts to become comparable to the attractive force, a burst in radiation occurs. In the simulation, the distance...
This burst of radiation is ongoing in galaxies and suns. The Birkeland currents aren't going back and forth like you see here. They're stationary.
It's equated to about the order of several pinch radii. This interaction between the 2 Birkeland currents is something that we will explore in the next video. As always,
And I have a second one here that just came out last Saturday. It's Don Scott talking about Birkeland currents.
My model predicted,
and this is his model here. You see the direction of flow on the interior tube is going this direction, and the exterior tube is also going in that direction. But these tubes, the direction is changing. And in this one in the center here, like these are counter-rotating tubes within these Birkeland current. This is a more finely detailed model of those ones that I told you were just simple versions of it. Basically, a Birkeland current is AC current. It's flowing in both directions.
Coaxial counter-rotational motion of their internal plasma, and are able to carry electric current in both directions at the same time. Let me emphasize, this is a unique behavior. A coaxial cable here on Earth cannot simultaneously carry current in both directions. As far as we know, true coaxial counter-rotation is created in nature only by field-aligned, that is to say, Birkeland currents. For example, a pair of tornadoes located near each other, rotating in opposite directions, is not an example of coaxial counter-rotation, simply because they're not coaxial, they're not inside one another. So when NASA recorded those coaxial counter-rotating cloud bands on both Jupiter and Saturn, my model had passed its first test. That was the extent of my first foray into this cosmological jungle, and at that point I figuratively pitched camp for a rest. But then announcement of the discovery of counter-rotating stars in the faces of several spiral galaxies was even stronger evidence I was headed in the right direction. In 2014, it was reported that a vast network of plasma filaments, Birkeland currents really, had been discovered that connects many, if not all, the galaxies in the universe in what has been called the intergalactic web. The discovery was quickly confirmed, and a rush of scientific papers followed. All this strongly suggested that Birkeland currents not only connect objects within our solar system, but there are much larger and stronger Birkeland currents arching across the vast distances between galaxies. I assumed that those galaxies within the intergalactic web must be sending and receiving electric currents via the plasma filaments to which they are connected. Also, I thought if galaxies actually form on those Birkeland current filaments in the web, they probably inherit their rotational profiles from those filaments.
Recently, it has been discovered that, as I told you before, these filaments are twisting. They're moving. The individual galaxies on them sit 90 degrees on their filament, on their portion of the filament. All galaxies on the Birkeland, on the cosmic web, sit 90 degrees on their filament.
If that happens, then
that's important.
Velocity profiles ought to be the same as the velocity profiles of the Birkeland currents on which they form. Remember that the typical stellar velocity profile in a galaxy has been totally baffling to astrophysicists. Actually, they typically look like a plot of the function, the square root of r. This shape cannot be explained by Newtonian physics, and almost all astrophysicists deny that electrical effects could possibly produce any of what we see in the cosmos. So that's why astronomers like Vera Rubin and her colleagues postulated the existence of dark missing matter in the 1940s. Their repeated unsuccessful attempts to explain this rotation of those stars is what set astronomers off on their decades-old quest to find dark matter.
That's the rotation curve, what is observed and what they calculated for all the visible mass that we see, and it was lacking, so they decided to make dark matter. So this is understanding Alfvén's circuit within 60 seconds, so I'll just play this.
Alfvén's galactic circuit is a concept proposed by Hannes Alfvén that a collapsing plasma cloud will naturally form a rotating...
Low volume.
This will create a rotating magnetic field which will drive a current system out of the axis of rotation, outwards and back around and in via the plane of rotation. And this would mean that stars would form along the incoming current sheet which would naturally form filament structures. We can readily see the stars do indeed form along these filament structures. And we also see that stars have a relative motion to this filament. There is evidence to suggest that there is an inward flow of the motion, but more work needs to be carried out to conclusively prove this point. The most important thing to remember in Alfvén's galactic circuit is that the current flows out from the poles and back in via the plane of rotation. I've often wondered what drives the huge electrical currents that we see flowing across the universe. The Thunderbolts project often refer to Alfvén's galactic circuit. So let's explore what this is and how he came up with the idea. This story starts with the discovery of a strange double radio source. These were one of the most puzzling problems in astrophysics at the time, and we're talking the 1970s. These sources were emitting huge amounts of energy and often had a galaxy situated right between the two sources. At the time, there were two explanations for these. One line suggested that there are stellar objects at the center of each of the radio sources which were emitting radio, essentially like radio stars. None, however, have ever been found. The other theory suggests that the galaxy at the center has emitted two jets in opposite directions, which in some way have been kept together during their long travels. None of these models could explain where the energy to power this double source actually came from. Modern theory still suggests that these are caused by active galactic nuclei producing two persistent, oppositely directed plasma outflows that contain cosmic ray electrons and magnetic fields. It is believed that these plasma jets are formed by the accretion disk that form around a massive black hole like the one at M87. Here, the jets are powered by the accretion disk, and we're not going to discuss the problems with this model in this video.
Hey, Mom. Thank you, Mom. Thanks, Mom.
Sorry.
Did you know that PetSmart has auto ship? Well, now you do. Shop anything, anyway. PetSmart. Anything for pets.
Alfvén goes on to discuss the main problems he faced at the time regarding the approach to plasma physics. Current plasma physics has moved on significantly and adopted many of Alfvén's ideas, but let's briefly cover his main gripes. He points out that many plasma phenomena are ignored by cosmologists, listing them as follows: electrostatic double layers, current sheath, pinch effect, and critical velocity. He points out that plasma cannot simply be studied by calculations, as the behavior can often be very complicated and require in situ measurements.
Yep.
And it is important that a new approach is needed and should be based on the recognition of the fact that the plasma has general patterns of behavior, which in important respects are the same in the laboratory and in the ionosphere, the magnetosphere, and the heliosphere, and these results can possibly be used to extrapolate further out. In this paper, he intends to demonstrate that certain observed processes in the laboratory may be used to explain these double radio sources. When an electric current is passed in a discharge tube, it often produces electrostatic double layers. This is nothing new, and it's been known for about 100 years. These double layers will form even if there is no magnetic field present, and this will cause an acceleration to the charged particles and no appreciable electric field. Double layers are often produced at the point where the diameter of the discharge tube changes. The energy released in the double layer can be so large that it can cause the glass tube to glow or even implode. These double layers often oscillate and emit noise with a broadband frequency spectrum. In this setup, the power is supplied by a voltage source in the circuit, which could be located at any distance from the setup. The energy is transferred to the double layer through the electrical circuit, and the behavior of the double layer depends not only on the plasma parameters near it, but also on the resistance and the inductance in the whole circuit. Larger inductance would cause the double layer to explode, and as the circuit is broken, the magnetic energy is released very rapidly. This means that the plasma column can be likened to a metal wire surrounded by an insulator, and the double layer as a non-linear circuit element. We know that at the dawn side of the auroral zone, there are currents.
This is what I was talking about the sun side of the Earth and the dark side of the Earth having different electric potential.
Flowing into the auroral zone at high latitudes and leaving the zone at lower latitudes. At the evening side, these currents will be reversed. These currents flow in sheets along the magnetic field lines and are called Birkeland currents. The circuit is closed in the upper ionosphere and in the plasma near the equatorial plane. A spacecraft passing over these would measure a voltage inversion. Above the double layers, the equipotential lines form cylinders around the current-carrying flux tube, similar to what happens in the laboratory. Below the double layer, there is a beam of high-energy electrons accelerated.
Again, this is a simplified version. We're looking at tubes within tubes within tubes within tubes of these Birkeland currents, these counter-rotating tubes that the center of all the heavier elements gather in the center, and all the lighter elements like hydrogen around the outside of the Birkeland current.
Mm-hmm.
That's key as well.
At least in part in the double layer. Most of their energy is dissipated in the ionosphere where they produce the aurora. Again, this is similar to the laboratory experiments where the charged particles are accelerated in the tube. He identifies that the main sources of this energy in the magnetosphere circuit is the kinetic energy of the sunward plasma due to the solar wind. To date, only the equatorial plane current system has been measured. These show that the radial component of the current is about 3 times 10 to the 9 amps. From Kirchhoff's law, we can conclude that this current flowing towards the sun must be closed by currents leaving the sun, which means that there must be a high latitude outward current, which in the case of symmetry would be 1.5 times 10 to the 9.
And we have measured electrons leaving and coming into the sun from the north and south poles of the sun. It's basically circuitry.
Amps in each hemisphere. How close to the axis these currents flow is unknown, but it is highly likely that the polar plumes in the solar corona mark their footprint. If we compare the heliospheric and the auroral current system, we may see similarities. However, there are some important modifications that need to be made. Number 1, the main EMF is produced by the sun, which acts as a unipolar inductor. Now, by unipolar inductor, what we're talking about here is a rotating magnetic field with a conducting medium inside of it. And when that rotates, it generates an electric current. So it's effectively acting like a sort of a generator. It is producing through the rotation a potential difference which will drive the current flow. Number 2, as the current is large enough to modify the dipole field considerably, and because of the solar wind, the equatorial current extends over a very large region and is spiraling. Further, the poleward branch of the Birkeland current is moved close to the axis. This circuit must be closed at a great distance from our sun. But if the analogy from the auroral circuit is true, we must expect to find a double layer high above the sun in the polar areas, probably located on the axis. If we take the heliospheric circuit and we replace the sun with a galaxy, which equally has a magnetic field and is also rotating, we would expect a similar current system. Inside the galaxy, the current may flow in the plane of symmetry, similar to the current sheets in the equatorial plane of the sun.
Oh my God. That's enough of that one. I think you guys get the idea of Alphane's circuitry. And now we'll move on to the electric model of the sun here. We've got 15 more minutes to go. How are we doing for time, Harry?
Yeah, it looks like 22 minutes have elapsed, so I guess that's 15, 18 minutes.
Okay, perfect.
Was it the Toho wall and the ones they flew up over? They said they flew it over the poles of the sun.
Oh, Ulysses.
Ulysses, yeah. Yes. And so then they talked about.
They saw this magnetic field curled around out of the polar region.
Exactly.
Yes. That's in one of your papers that you sent me as well. That I was going to ask about the twisting outwards, which to me that kind of screams that there is something coming in to cause that kind of twisting outwards.
That lotus shaped.
Yeah.
Yeah.
One question.
I think the current coming in at both poles is down to treating the sun as sitting in its own magnetosphere, if you like. And this whole heliosphere is the boundary of the magnetosphere.
Heliopause.
And the current from the central column will try and come in at the poles, just like it does with the Earth. And since we're enveloped in this more positive central column, in effect, the positive charge, if you like, is coming in at the poles and out of the equator, and that sort of completes the circuit, because the equatorial current sheet then goes out to the more negative first cylinder.
This is basically the Birkeland current system.
All of that, where things are really heated up and you can see what's going on. It will go out to the second cylinder as well. And where it intersects, you get those.
This is about the heliopause here.
Supernova, for instance, and also that right at the very pinch is where the current drifts from the central column to the return circuit, if you like.
Yeah, I kind of describe that as like a bleeding out.
I couldn't agree more with that. That one picture that Paul showed, the M29. That's that M. That just about.
You can see the Bennett pinch right here.
I think the M would be Messier, and the Messier 31, and Messier 32, and all that. It's not. It's Minkowski, and it was named after the son of the Minkowski who got involved with Minkowski space and Einstein. But his son was also an astronomer, and so that M29 is Minkowski 2-9. But I think that
double layers
says it all. Absolutely.
Yes. Beautiful picture.
There is actually, it's slightly off.
You can see this because it's in glow mode. Highly energetic compared to our sun.
Topic, but there is, I've seen an animated version of, I'm not sure whether it's the M29, the one that you're talking about, but it shows
twisting.
You see in that diagram, you can see the shells really clearly, and there's this beautiful color, and you can clearly see that there is a shell within a shell. There's like layers in there, but there's an app.
And I'm guessing that this twisting motion has got to do with something to do with the rotation of that star or object.
Animated one where I can see that there is rotation in some of those shells. You don't necessarily see movement in and out, but there is clearly sort of rotation going on around. I'll see if I can dig it out, and I'll send you the animation of it, because someone posted it in the comment, and I looked at it and I was like, wow, that's quite a find, really.
Another thing about that diagram that I think is really important is if you look out at the ends of the thing, it gets dimmer and dimmer and dimmer, and finally it looks as though that's the end of it. It's not. That is simply the Birkeland current is in glow mode where you see it, and at the center it's in arc mode, right at the central star or whatever the center of the nucleus of that thing is. And then if you go farther out in either direction, the plasma just goes into dark mode, and so it's invisible. Yeah. So I think that's another little chink of evidence that's saying, yes, it's a Birkeland current, yes, it's plasma. And we know that plasma comes in 3 operating modes: dark mode, glow mode, and arc mode. And there it is in front of your eyes.
Right there.
That's right.
All three modes.
Too, which I think this is just a detail, but those flyers, the fast low ionization emission regions that sit along the axis away from the central star, these are Hans-Alfvén's double layers.
Right here.
Yes, exactly. Yeah, the ones that you see, the little, they're like, I know what you mean, like imperfections in that look like it's being pulled in one direction or the other. Well, it's
one of the interesting aspects of that is they have the shape. Sorry, Don.
No,
I was just going to say, one of the things you see in some of the best pictures of them is that they have the same shape as the plasmoid from the dense plasma focus gun.
Yeah.
So you've got the streamers coming into the central column.
That cone shape.
Yeah, I see what you're saying. Yeah.
So there's even more to it than just plain double layer.
Yeah. Going back to the solar wind and the fact that the ions kind of move out. One question, as I was building the animations, is if we assume there's like an electron shell that sits outside of the heliopause, which is obviously where the electrons are being drawn inwards, surely some of the ions that leave through the solar wind would end up being neutralized by some of the electrons in that shell, wouldn't they? Or we're talking... That's where the excited little atoms come from. Well, but we talked about that, and that's almost the next shell out that we would be looking at for that, wouldn't? Because
I think
I would like to point out that this image here that you're looking at is just a computer-generated image of what's going on with the ions and electrons. The sun's here. Earth is probably right about here, like right beside that white dot. We're looking at hundreds and hundreds and hundreds of AU here. This is the Birkeland current. If it followed up, it would go up to here, and it's pinching in at this point right here.
I think we have to. I do know that yes, the cathode, in a plasma discharge in the laboratory, the ions only live within the cylinder. The ions don't travel in wires. Okay, so obviously, if there's a positive ion setting in the plasma toward the cathode, it's going to get an electron, which does travel in the wire and jumps out of the cathode and connects with that anode with that ion and becomes a neutral. Yeah, but when that IBEX mission started talking about these excited neutral atoms and having a whole bunch of them there, I said, "Amen, brother, man. That's right. That's got to happen. If that is what happens right in front of the cathode of every plasma experiment in the laboratory." Sure.
Yeah, actually, I think it's
a little more confirmation. I mean, he's talking about what's going on outside the stellar environment, and it matches what they see in the laboratory on a smaller scale, more scalability.
At the cathode region, you get that voltage drop.
Yep.
And we have to look at anomalous cosmic rays to see whether they may have an origin, because they think that they're caused by in the standard model anyway, by the motion of the sun, through the interstellar material and collisions and whatnot, accelerate electrons or cosmic rays there. So I think that probably happens at the cathode drop, but the very fact that the anomalous neutral atoms show a ring pattern.
Oh my God!
My McNugget dip.
You put it on your McCrispy.
Even.
At some distance beyond the solar system, well beyond. And the fact that they change over time and they have bright spots that move and change in a matter of months, all of that suggests that it's actually the first cylinder because out at that boundary of the solar of the heliosphere, you've got it's a non-collisional plasma pretty much. So some ions, of course, from the solar wind will be neutralized at that point, but there are plenty that will get through to the outer cylinders. And
leakage through the double layers.
These ENAs are being accelerated back into the solar system means that they must be striking some electrical current which is causing them to orbit. And it's the ones that are neutralized when they're on the inward part of their orbit that come back into the solar system. The other ones go straight out. And so I think that's the pattern that we're looking at. So I do think it is the first ring of the cylinder, Birkeland current cylinder.
Yeah, it sounds reasonable. Yeah, Markland, and the founder, discoverer, the inventor, what's the right term? Markland convection. Göran Markland said that what was happening there at the outside of a Birkeland current is the hot part. Inside the central part of a Birkeland current is where it's cool, but cool in respect to the outer one. But what happens is that the Markland convection is due to the fact that these ions become ionized in order of their ionization potential. That is to say, at the center of the Birkeland current, what you find is iron and stuff like that, and then it's easily ionized material. So there's a lot of charge there. And if you look at my second paper,
the iron will move inward.
If the Birkeland current shows, if it corresponds to the velocity profile of a galaxy,
any heavy element will move inward, and the hydrogen will be on the outside.
Where the heaviest charge concentration, rho, the coulombs per cubic meter, is the highest, and then that ends up giving you a potential, a drop, essentially a linear slope downward of voltage, and that is an E field, and then the E field is what pushes these ions out. And so, just as with, if Jurgens is right and I'm right and Wall's right, the tuft, the anode tuft produces this downward dropping voltage, and therefore accelerates positive ions out, and therefore at the bottom of that chute-to-chute, there's a tremendous turbulence and collisions, and that's where the sun's super duper high temperature, 2 million Kelvin, comes from. But that's a sort of a micro analogy to what happens at the Birkeland current, because that these ions that are coming down that decreasing voltage, they have collisions on the outside there, and that's what makes the outside of the Birkeland current hot. And that's where the hardest to ionize elements like hydrogen and helium form. Then, along with the introduction to the fact, and then, well, what happens then? Well, these neutrals have been diffusing because the neutrals are not affected by an electric field. So the neutrals diffuse into the Birkeland current by a diffusion gradient, and then they're ionized and they go back out as ions. So that's too could be why there are neutral atoms coming in, as Wall is saying, at that juncture there. Because if this thing is, and I think Wall and I both agree that if we are inside of Birkeland current, it's probably a pretty old one because it's in dark mode. Otherwise, we see a tremendous display in the sky. If this thing were in glow mode, holy smoke, you wouldn't see the other stars. But so it is in dark mode, but it's still there. And if it all is working cohesively, consistently with the way we know Birkeland currents to work, then that's where there is a diffusion of neutral atoms coming in there. Mikowski 2.
Oh my God! I didn't expect that. 1 second.
Your risk.
All right,
I just want to point something out.
we're gonna get cut off here.
You can find your winning strategy, which the Clustrade gets 1 month of free options.
Renovation,
Oh my God.
innovation, but the bath fitter PermaFit solution. We measure with laser precision so your tub fits perfectly. With watertight walls that are drought free and easy to clean. Smart, cost effective, and guaranteed for life.
All right, we got like 2 minutes.
Okay.
Good night.
Well, his comment about us living, like if this is a star and there's planets orbiting around it, we wouldn't be able to see the stars outside that sheath. All that light would be overriding all of these points of light. And in a later talk, I'll talk about
All right.
the expanding sheaths of some suns. Okay, we're basically finished.
Okay, we got like a minute or so. All right, that was interesting. So, do you have anything else to any other videos?
No, that was
discussion.
That was
so
it.
We can have,
we can have a discussion on the next session. Yeah.
Well,
Okay.
Rick, that was, I think you hit the ball out of the park presentation. Thank you. I do have a number of questions, though. I'll say
I was nervous as hell.
You didn't sound it.
Thank you.
Okay. All right, we got a minute. We can either sit in silence or I could stop it, or
I would like to just say that this fella here, Gareth from See the Path,
Not as easy as it seems, somebody boy.
Saturn. If you want to learn about the electric universe, go to his site. I know you all you guys like his work. He points out a bunch of different theories and compares them, and you'll see he leans towards the electric universe as well.
okay. I did want to mention that Wall Thornhill was the guy that was talking, who was
right, yeah,
on the top right, and Don Scott was on the
bottom right. Bottom right.
And I guess that recording is fairly old because I think they both died.
Yes, yeah. No, Don Scott's still alive.
Okay, all right.
Wallace Thornhill has passed away now.
Yes, I know
about
that.
2 years ago.
Okay.
When we come back, I still want to show you the Birkeland current model. That's one thing I didn't show you. I'll request.
Well, I'm not sure where to start here. I know that Jim said he had a bunch of questions. I don't see him here.
Just playing. That was good, buddy.
I'm here.
Yeah. Ian, do you have any comments or?
Well, I suppose yes. I'm perhaps a general comment, Harry and Rick, would be that I must concede that it's an impressive sort of model for explaining a lot of these phenomena, or looking at these phenomena and how they actually arise. It's interesting. But I have a fundamental matter, which I have raised on previous occasions, and it was prompted by the shapes of the galaxies and so on, being formed experimentally as well, I think, in the laboratory, you said, on a smaller scale. And the concentration on these distant galaxies and so on, and the spiral arms and the dark matter postulation to save existing general relativity or whatever. But my point is that both conventional theories and perhaps alternative theories, such as the electric universe, are concentrating on what I would consider a non-problem, because they're both conventionally and from the distant point of view, they're looking at these very distant galaxies as being snapshots in time, but they're not. By definition, they cannot be, because any element that we see in a distant galaxy or nebula must satisfy the criterion that the light emanating from that must be the same distance away from us in light years as the time before the present that it emitted that light in years, because it has to give the light time for it to reach that point. So in other words, if there's
we're looking back in time.
We're looking back in time, but I don't know if you quite understand my point. If there's an element that's a bit further back than what I have just described, the light won't have reached us yet. It could take another million years, so it'll be black by definition. On the other hand, something which is nearer than the criterion I've just given, the light will have gone past us maybe a million years ago. So
yeah, but we're seeing
the composite image.
But what we're seeing with Hubble, when it took its first deep image, we were shocked, weren't we? Look at all that stuff out there in that black area of space. And now we've put Webb out there, and we've seen stuff even further back. They say it's highly redshifted. We're getting redshifts of up to 30 now. This is ridiculous. This is tired light. This is light that's been traveling forever. And it's so dark that you have to have a wicked telescope and leave it sit there for hours and hours and hours and hours to even perceive that light. Well, guess what's going to happen on the next telescope? They're going to find stuff that's even deeper out there, and deeper and deeper and deeper and deeper every next telescope that goes out there. They will not find an end to this galaxy or this universe because it's unknowable. Its extent is unknowable with our current technology. There's nobody. If somebody tries to tell you that the galaxy or the universe is this age or this big, tell them to take a walk, because we just don't know. We will never know. Yes, I know that, Ian, and we agree on lots of points, and we disagree. We seem to disagree on a bunch of points, but that's the nature.
Can we?
Speaking.
I hate to interrupt this, but can we get to some specific technical questions?
Right. I just wanted to point out this is etherealmatters.org. And this is James Sorensen's and Donald Scott's model of the Birkeland current. And here's the values of force Bessel function for all of these cylinders within cylinders. This is how we know that Birkeland currents are structured. We've measured them, we've seen them, we've put probes through them now. And just recently, like in the last video, we've put probes in the northern pole of the sun, and we see this structure, this spiraling structure. It's feeding electrons into the sun. That's how it gets its power. It's not internally powered by an atomic reaction.
Perhaps one more thing, which is a bit more of a question, but it's still general. I'm not specifically asking you about how.
Let me just finish with one point. James Sorensen has also done work with Ito on his structured atom model. When you go to the structured atom model website, you'll see James Sorensen's work as well there. So go ahead. Sorry, Ian.
It's just that there has been some debate when we're looking at electromagnetic theories and so on. as to what comes first, a bit of a chicken and egg. So, for example, well, what's his name? Bob, just forgotten the surname now. He's done a lot of theoretical work. And he claims that it's basically the magnetic field which comes first. That's the origin of everything. And the electric field is not that. Now, some people...
Talking about Bob Gray.
Bob Gray, exactly. Yeah. So your theory seems to be the opposite. You seem to be considering the electric field as fundamental.
In wires, in experiments, Maxwell, all of those guys, they knew that without moving charge, which is what you're looking at right here, Birkeland current, moving charge gives rise to magnetic fields. Without that movement of charge, you will not have a magnetic field. Will not.
It is interesting that the mainstream talks about all kinds of things with the word magnetic in cosmology, magnetic ropes, magnetic connections, etc. Yet the electric component, which must be there, as Rick just pointed out, is completely ignored. So that's a bit strange, right? If you have these huge magnetic...
Because they don't want to admit that there's electric charge everywhere, giving rise to these magnetic fields that we see in deep space. That's how we figured out that we have a cosmic web, is because we measured all these magnetic fields out there, and we found out the structure of it. And now we're seeing that this web rotates.
Do we have sort of an artificial like choosing of teams here that are against each other? Like you say, they don't recognize.
Well, that's just the mainstream. I mean the mainstream.
Mainstream. I've been hearing about magnetic fields in mainstream all my life, and so
we're not talking about magnetic fields. We're talking about charge. They leave out the charge, the aspect of these magnetic fields
so
that,
you're
that
saying
create
in
these
the
magnetic
magnet
fields.
I have on my table from a speaker that I took apart. That magnet, there's electric charge moving around in there, and that causes
No. The reason why your magnet is a magnet is because all of the atoms are aligned in a certain direction.
Well, now you're contradicting yourself, because just a moment ago you were saying that the charges had to be moving around.
Yeah, but
you're saying the charges have to be aligned.
Do we have a physical magnet out in space creating all these magnets? There's a huge difference. Well, we don't have these physical magnets out in space creating these magnetic fields. What we have is field-aligned currents, Birkeland currents, creating those magnetic fields.
There's a difference between permanent magnet and electromagnetics, right? It's different. Yep. The assumption is that there are moving charges within a permanent magnet. I would offer that is very debatable, but that's something else right now.
Okay, I have a question. Do these electric currents exist inside of the Earth? These Birkeland currents? Do they exist inside of the Earth?
Not in this form. I would think. I would think that they're like a single tube of current going in one direction. We call them telluric currents. We know that they exist inside the Earth.
Well, does the electric universe have it seemed to me that you need to have a theory of how the Earth's magnetic field is created if you really want to. I don't really see any mention of that in these videos. Are there any videos that address that?
I believe there's one or two videos that express the fact that we have all of these electrons not only going in to the aurora and then going out, but many of these electrons pass through that and go right into the core. Don Scott says that the Earth receives about 10 million amps every second of every day.
That's not what I'm talking about. I'm talking about
there is
what's going on inside of the Earth, or there
right. Well, I was getting to it.
I have an answer there.
I was getting to that. I was going to say that we think that there's a plasmoid inside the Earth.
No.
That is being fed electric energy from the pole regions. Ito, go ahead.
There's a better answer. I'm so sorry, Rick. I don't mean to diss you here.
Well, that's basically what most
one
people
of
in
the
the
proposals, right?
That's one of the most people in the electric universe think that there's a plasmoid at the center of the Earth, not a hot ball of there may be iron in there, a hot ball of iron, because it's being
There's somebody
charged.
way better, Bruce Laybourne.
Bruce Laybourne
is a real deal scientist, meaning in geology, and I'm talking about penetrating the Earth and figuring out what the Earth looks like and all that kind of stuff. Full-fledged geologist. He has done a lot of research throughout his career, and he talked at the Electric Universe as well. That's why I know about it. And he basically gives the entire answer to the question here, Harry. He talks about how the Earth is a complete electromagnetic system, and he explains how and why and all the nitty-gritty detail. I think it would be awesome to have him as a presenter, but that is just my preference there. But he would, it's a whole presentation and then some to answer your question, but it is there, Bruce Laybourne.
Could you ask him, Ito? I don't have.
I can make an attempt to reach out, but sure. If that's
okay, I didn't quite get what's his name? Bruce.
Bruce Laybourne.
How do you spell that?
Leyburnne. I'm not sure about the U.
Okay. All right. Well, this is what. Well, okay. I'm going to let other people talk here. This is kind of getting into my wheelhouse and some of the issues. Anybody else have any comments before I launch into
I think that Rick is or not Rick necessarily, but this whole electric universe thing is mixing branding with the physics of the phenomena. It's like we have Coke, that's the phenomena, and branding is a refreshing drink. I don't think these things should be mixed. And I could summarize this concept by the content of today's talk was four things: phenomena like Birkeland current, Bennett pinching, physics theory to explain the phenomena. That's a second whole other topic. Also astronomical observations. That's the third thing. And then fourth, you have how is it related to cosmology? So to mix all of these things, those could be four separate talks. For me, as a beginner in what these phenomena actually are, I'd like to see a talk, not necessarily by Rick, but by somebody, as what the phenomena are in terms of the data and measurements done to define it. Birkeland current, what is it? Pinching, what Bennett pinching, and any other third or fourth phenomena you've got. Forget about cosmology. I don't want to hear anything about cosmology in that talk. I don't even want to hear anything about physics theory. All I want to hear is how those phenomena are defined. That's part one. And then I gave the total 4 parts of your content today. Then we can go to 2, 3, and 4.
Right.
Well, I thought Rick did address some of those issues to the best of his ability, I thought.
I'm not scientifically minded, like Harry's just mentioned, and I'm just trying to give you as much coherent information as possible.
Well, you did a great job, Rick. You did a great job at that. I'm not criticizing you or your presentation. As I said a moment ago, you hit the ball out of the park with bases loaded. Okay.
Thank you. Well, like I say, I'm just trying to with me talking about the discovery of Birkeland currents in 1967, right? And then, in 63, they put up the probe, and it took 4 years for them to run through the calculations and see what was going on and confirm that in fact it is a Birkeland current. That's what's going on there. We still have a few years ahead of us with the sun.
Topic 3 in your talk, astronomical observations.
Right. Well, it's hard to break them up into individual portions because they need to be put together to understand the whole system.
Well, maybe some of those astronomical observations have some error in them. I'd like to know what was actually measured, what the assumptions were, and what the conclusions of the investigators were as a separate item.
James, I invite you to research that yourself because that goes far beyond my wheelhouse.
Yeah,
I'm not a scientist. So
aside from congratulating you on you covered 4 areas as far as I'm concerned, and tried to put them together. But discussion of all of these 4 in a forum such as this is very difficult. Because there are a number of issues in each of these 4 topic areas. And
well, again, if you want to, pick apart the issues that you have and ask me about them later on, I can possibly answer them, or I can point you to YouTube videos, Thunderbolts videos that would more than likely answer your questions. Okay. But again, a lot of the math for all of this isn't set. But again, some of it is, like Birkeland currents. Don Scott's work you're looking at right here involves all the math that you need to know. There's Birkeland current equations that.
It looks like
that are in Birkeland's papers. Like here's the math. Here's some of the math here. He's got this is 100 years old. So, I mean,
it seems like the electric universe people are mixing the branding with the science. In other words, why are we talking about the electric universe? Why aren't we just talking about the universe?
Well, the electric universe is because electricity, we think, is the main driver of the phenomena that we see out there. It's gravity is just basically a participant.
See, that's what I talk about branding. My findings are the main important thing. That's branding. That's not science. That's not astrophysics. It's not experimental.
But it is. Gravity is 10 to the 39th power weaker than the electric force.
Well, you haven't even set forth how we get out of atoms in the first place, or nuclei in those atoms in the first place.
Well, that would be Ito's wheelhouse.
Factor in the universe.
That would be Ito's wheelhouse.
When you say this is the main thing in the universe, that's a branding. That's not a scientist talking.
That's the main. It's the main force at work in the universe.
Well, that's why I think a lot of these phenomena.
Can I offer a reply?
Current discovery, Bennett pinching is supposedly a discovery. Why mainstream is, you said yourself, is ignoring this, Rick. And I think they're ignoring it.
Well, they don't ignore Bennett pinches. They know they're real.
Branding. It's the main thing. It's the electric universe. It's not astrophysics we're talking about here. We're talking about the main important thing in everything. That's branding. That's not astrophysics. That's not physics.
Well, you can call it branding, and I call it the main contributor to what we see out there. The main force that applies its what's the word I'm looking for? The main force that applies its force over vast distances that gravity can't even reach.
Well, what about all the other things, like the atom, for example?
What about the atom?
We're not talking about gravity there. In other words, the characters in your screenplay, in your movie, are the atoms and the particles. You said nothing about where they come from, what they are, any
They exist
theoretical?
on the Birkeland current. They're everywhere.
According to your branding, is you can only go so far as to say is that they exist.
Christian Birkeland expressed the thought that there is a ton of dark matter that we cannot measure because it's microscopic and it's everywhere out in beyond the
and yet the very
influence of our sun
is not have any part or any explanation.
Can I offer a reply?
The plasmic universe.
Well, you could call it the plasma universe, or you could call it the electric universe, but that's just a descriptor of what it is.
I guess I made the point.
I would say that what they're proposing is a kind of an alternative physics paradigm.
No, it's not an alternative. It's just an addition to the present.
Well,
paradigm.
I think it's an alternative paradigm.
Well, they're presenting it as an alternative.
Well, we say that all you have to do is add the electric force into the model of cosmology, and you'll have a way better picture of what's going on. All the phenomena can be explained through electric forces, magnetism, and electric charge.
It's the main thing, rather than an auxiliary to other forces. You're concentrating.
Well, you have to give gravity its due because it does do work out in the cosmos, but the majority of the work is done by electric currents and the magnetic fields that they create.
That's the paradigm. You just said the paradigm.
Mainstream does not reject that the electric force or electromagnetic force is much stronger than gravitational force.
No, they don't reject that at all.
But
they do not
like you're creating an artificial barrier between the physics you're reporting and the mainstream thinking.
James, they do not recognize electric current in space. They do not recognize it.
That's not true. That's not true.
They only recently started to admit that there is electric current out in space. There's been only in the last 10 years, there's only been a few papers that talk about electric current out in space.
Out in space?
In the cosmos.
Inside a fluorescent light bulb.
In the cosmos. What about it? That stuff is well known. That's Ampere's law. That's Maxwell's law. That's all of that electrical phenomena is well known.
So why wouldn't it be well known and well accepted that the phenomena could occur elsewhere than
because it's fringe science, Jim?
Because it's fringe science. Exactly. Because they think that the stars are powered by atomic reactions at their core. They think that they're islands out in space by themselves. They don't realize that everything is connected with everything else along these Birkeland currents, and these charges, this flow of charge everywhere is responsible for what we see. Not gravity, but electricity.
That's a alternative paradigm, which Jim refers to as branding. The paradigm that is Jim refers to as branding. So it's a proposed
alternative paradigms are mainstream.
No,
that's what every PhD physics project and every research lab in physics departments and national labs around the world are doing. They're looking for alternative. They're looking for alternative to do an experiment which will clarify a phenomena by perhaps discovering some alternative variable that affects it or whatever. So this whole
you don't really understand what paradigm means. Paradigm is the overarching belief system that is adopted. And the overarching belief system adopted by mainstream is that gravity, as far as cosmology is concerned, is the main
king.
player.
Okay, I
And-
can accept that way of looking at it. All right.
Do you see this image here that I'm pointing to, fellas? This Torella experiment?
Yes.
This reminds me of Io would be sitting right here, and this is Jupiter, and this is the interaction between Io and Jupiter. This is our aurora. I mean,
is this a simulation or some?
Yes, this is a Torella. This is
What book is this that you're showing us?
This is
that
Christian
a photograph
Berkman.
by
Norwegian
a
Aurora
spacecraft
Polaris
or-
Experiment, 1902-1903. That's the title of the book.
All right, let me just point out this
paper.
Torella thing is a magnetized model of the planet.
Yeah, it's just a magnetic ball.
Right, it's a model of the Earth, basically.
Yeah, yeah.
Uh-huh.
Can I make a comment here in between?
Go ahead.
Thank you. Responding to Jim a little bit, I understand your critique, sir, very much. I myself am very critical of the electric universe group or phenomena or paradigm. Take your pick. Myself, in many ways, there are people and presentations and ideas there that I definitely do not support. However, looking at the bigger picture, and I'll speak for myself, but I think there are many resonating with that. I was trained in the standard model, physics, chemistry, biology, cosmology, you name it, that kind of stuff. My own speciality being chemistry, environment, and that kind of thing. Then I learned there's a lot of problems with that. And there are no two explanations with that. In short, I became completely disillusioned and very unhappy with the state of affairs in standard model physics and science in general. Many people walk away. Many people find the electric universe. The reason they go there, because there is work there that deserves attention. In my personal opinion, a lot of attention. However, it is a collective. It is a paradigm shift or a group of people trying to do something. There's a really beautiful word for that. It is a grassroots supported movement, supported by people that truly want to know, that truly want to figure it out. Most of them love science. All of those people that I've met, they love science, just like the people here. However, many, not all of them, but are not trained properly in scientific terms. They are there. Professor Donald Scott is a true, real scientist with a real career, just like everybody else here. However, Jim, you are correct. There's a lot of criticism, but that is because there is no university supporting this. There is no leading character anymore. There is so much work to be done. There is new experiments to be done. There is money needed, etc., etc. So it's easy for us to critique it, and the critique is deserved. Don't get me wrong. I fully disagree with Wolf Thornhill, our previous captain. Rest in peace, my friend. But there are many things I do agree with him, but not on an atomic level, for example,
or gravity.
Atoms would be in space. But you know, what united us is our curiosity. Our true curiosity in scientific explanation. We want to know, and the standard model, with all due respect for the people that are into that, completely let us down. That's why so many people go there.
So
That's what I wanted to say.
I scrolled to the first page of this book, Norwegian Aurora Polaris Expedition 1902 to 1903. Look at the rest of the title, On the Cause of Magnetic Storms and the Origin of Terrestrial Magnetism. He was thinking that the Earth is an electromagnet because it's being powered with these corpuscles, Birkeland currents, directly from the sun. That's what he thinks.
And I don't see any branding there. I see someone doing collecting data, presenting it, and trying to understand it. No branding.
Right. Well, I don't have a problem. I don't have a problem with branding at all. It's a question of whether it's correct or not, whether it's right or not, whether it's false or not. If it's false,
you give the so-called
you throw out the
mainstream.
theory. If it's true, then you accept the theory. And I think that the electric universe theory is the best theory of cosmology that we have today. The best. Sure, it could be refined, and later on, people will refine it to an even better state. But right now, it's all that we got.
Okay, well, that was a good summary. We'll take that as a summary of your position, and we got like 7 minutes.
Okay, you wanted to ask some questions, right, Harry?
Well, I have an issue with the where the source of energy is for these electric currents. And I kind of, in looking at what was, I never really, I saw the diagrams of the apparatus there show that there's a power supply with a voltage, but I don't really see where this voltage is and these electric currents that are coming out of the sun.
You see these electric currents that are happening within the Birkeland current itself.
I see this. The point is,
you have to understand that the charge is generated by this motion, by this potential between charges. That's how things start moving.
Yeah, but where's
the potential between charges,
the energy
positive and
coming
negative,
from that's driving this whole process?
This is where the energy is generated itself. It's self-generating.
I see this as a problem why it's not really going anywhere with the mainstream.
Yeah, but it's self-generating.
Self-generating sounds like perpetual motion. That's not going to fly with me.
On Earth, we need a power source. We need something to drive the electrons.
So that's why I asked about.
But this is natural.
The magnetic field of the Earth.
This is natural. This is a natural system that occurs naturally and has no need for an external power source on this end or this end to do what it does.
I think, Rick, it is a system that occurs naturally.
Space is not an empty vacuum. It's charged plasma.
Really, I don't disagree there. But you can't simply state that it is self-perpetuating. I'm with Harry there. The question Harry poses is an excellent one. It is the most asked one, and it is, I think, how Harry said it, preventing it from going mainstream, if you will. However, my personal philosophy there is, that is an excellent question. Let's look at it and let's research it. For all I know, I can think of something that is the fusion activity of a star system. They are pretty much isolated and connected through what they call the Birkeland currents, if it is exactly as portrayed here. That could be caused by a charge differential, and a charge differential could be caused by the amount of fusion going on or the activity of a star system fed by hydrogen
the positivity
into helium, for
of
example.
A star.
So now you do get a self-feeding system, but not a perpetual system. There's a reason there, right? The fusion actually yields an excess of energy, is exothermic in other words, that can drive a system. So there are potential answers here. I'm not saying this is true at all. I'm just postulating an answer is easily found, but nobody went there, I would argue.
It could be that it could be conversion of potential energy to kinetic energy.
Yeah, something like
for
that.
example, moving one little stone might cause an avalanche.
Well,
yeah, exactly. I mean, you would have to have initially one particle in motion. And that particle is in motion towards another particle of the opposite charge. That is the creation of motion. And then because they are electric in their nature, once they get close to each other, not like a magnet where a positive and negative combine, it repels. It actually repels at that point when it gets very close. And that's how we see the universe in motion and,
all right,
the creation of this charge that you see here.
Okay, we're coming to the end. Thank you for your discussion. I want to reiterate, we don't have anybody scheduled for next Sunday, so I'm inviting people to participate and give a presentation. Contact me. I want to thank Rick for giving this presentation, and thank him for that. So do you want to give any final? We got like 2 minutes.
One question.
No, go ahead.
One question only. What is the beginning of your electric universe? The beginning. Tell us. What is going on?
You can't ask that question because nobody knows. Nobody will know, and we just like the extent and the age of the universe. It's unknowable.
Okay.
Because
it's infinite.
Again, the universe is infinite, and the next telescope that goes up, you guys are going to see more stuff and further and further and further out, and they're going to have to change the age from 13.7 billion years to 25 billion years with the data that they're gathering from James Webb.
And do you tend to think it's eternal rather than that?
It's exactly my point.
It may be that the extent of the universe is there's no end to it. We just don't know with our current technology. It's going to take thousands and thousands and thousands of years of technology advance for us to be able to even start to answer those questions.
That's a paradigm statement of the paradigm of the electric universe, or at least your opinion of the paradigm, which is that the universe is eternal.
It's exactly eternal. My point. Eternal.
We just don't know. It may be eternal. It may be finite.
Well,
it may have an edge. Who knows?
One more question. One more. Right. Everybody knows that sun changes North Pole and South Pole each 11 years. What is going on with your model with sun? Each 11 years rotating.
I can't answer the flipping of the magnetic field every 11 years. I don't, maybe Don Scott could.
But it is experimental result. You must explain it.
Yes, I understand that. But again, I can't explain it, but Don Scott, he may be able to explain it. So if you want to write him an email and ask him.
Or just go to his website.
When I had a lot of heat on me.
No, that didn't happen. I wasn't prepared for that. Hold on. Okay, I gotta get to the other video, so there's another thing I was gonna say too. It would have helped, but I didn't write it down, and I didn't want to blur it in. So I sat on it and forgot it. That's usually the case with me. But there is a part 2, so let's watch this. I don't know if it's as long. We'll see. And I gotta get back to Discord here. Let me see. Okay, kill that one. Get back to Discord. Shockwave. There it is.
Okay, good morning, everybody. This is the cosmology discussion group meeting for.
Wait a minute, that might be the one I just showed. Okay, hold on. I thought I showed the second one first. Oh, lovely. Where is the second one? No, I'm a brain donor. No, it doesn't look like it's in the first. Hold on. I know they're here there. Okay, part 2. Tell me if this is...
Good morning. Okay, good morning, everybody. It's
Morning.
March 15, 2026. And we got St. Patrick's Day coming up. And winter, we had a brief respite from winter, and then it came back again. So, Ian, are you going to celebrate St. Patty's Day?
Well, yes and no. Whether I'm going to celebrate it particularly is an interesting thing, because do you remember James Aratoon? And his work on O'Reilly. Are you interested in this, Harry? So he's been threatening to come over to Ireland, and maybe I would help him to go down to University College Cork, where O'Reilly was professor and president later. So he's coming over, and we're going to be in Cork on St. Patrick's Day. So I met him last night. He's in Dublin at the moment. And we had dinner together. So we planned the week. He's gone down to Cork today. I'm going tomorrow. And we're going to spend all of Monday, which is the day before St. Patrick's Day, just going through the archives. And then we're going to we might look at the parade in Cork, or we might do a bit of touring there. And then I'm coming back to Dublin. And then he's coming back. He's going to stay with me 2 nights. He's here for the week. So
well, that's very interesting. I'm glad that that's coming to fruition, because Raleighy's book is very interesting and his work is very interesting, and hopefully we'll learn more about his work. Okay, thank you for that. Let's see, we have Rick Amelsfort to talk to us today about Halton ARP. And good morning to you.
Good morning. How's everybody?
Warm, thankfully.
I thought you said winter had come back.
Yeah, we had a storm on Thursday, and it snowed, and it was quite a big shock. The temperature dropped from mid-60s to mid-30s in a matter of a couple of hours. And it had been in the mid-80s. The temps here had been in the mid-80s. It was summer-like. It was really warm and hot. And then we had snow on Thursday.
Goodness me.
Okay.
Sounds like Canada.
It's a big shock for us here in Newport News. I mean, we're in the coastal Virginia.
Yeah. I know. It's usually warmer down there.
All right, we're ready to go.
Well, good morning, everybody. This is my presentation on Halton Chip ARP. Chip is his nickname. And it's about his findings on intrinsic redshift, which he calls intrinsic to quasars. Here's an overview. Halton ARP, 1927 to 2013, he began his career at the very heart of the scientific establishment, with ARP's PhD advisor of record being Walter Bade, and later Edwin Hubble, both titans of the 20th century astronomy. ARP arrived at the Mount Wilson and Palomar observatories as a graduate student from Caltech during the final years of Edwin Hubble's life. Assistant to Hubble, ARP worked directly under Hubble, helping to refine the distance scale of the universe. So he was working on figuring out redshift and expansion and all of that. ARP conducted a massive study of novae in the Andromeda galaxy M31, which provided a crucial standard candle for measuring galactic distances. And he had access to the 200-inch Hale telescope, then the most powerful instrument in the world. Following his PhD, ARP became a staff member at the Carnegie Institute of Washington. This was the most prolific and universally respected period. Discovery of interacting galaxies, ARP was among the first to prove that many peculiar shapes were caused by galaxies physically colliding or passing near one another. During this time, he was a mainstream star, widely cited for his impeccable observational skills and high-quality photographic plates. The turning point in ARP's career came when he began noticing, what he called discrepant redshifts. ARP found several instances where a high redshift quasar, which should be billions of light years away, appeared to be physically connected by a bridge of gas or dust plasma to a low redshift galaxy, which should be much closer. He proposed that redshift was not always caused by expansion of the universe, the Big Bang theory. Instead, he argued that quasars were offspring ejected from the nuclei of active galaxies, Seyfert galaxies, and that their high redshift was an intrinsic property of their young age. This challenged the Hubble law. If ARP is right, the Big Bang theory is fundamentally flawed. The astronomical community largely dismissed his findings as chance alignments, optical illusions. His loss of telescope time in a move that remains controversial today. The Palomar Allocation Committee denied ARP further time on the 200-inch telescope, arguing that his research was unproductive. And I'm going to butcher this name, Subramanian Chandrasekhar, editor of the Astrophysical Journal at the time, and a really big person in the field, wrote on his paper, "This exceeds my imagination." Well, if you don't have an imagination, what are you doing in cosmology? Feeling censored in the U.S., ARP moved to Munich, Germany to work on the Max Planck Institute for Astrophysics, where he later refined the intrinsic redshift model. He spent his remaining decades using X-ray data from the ROST satellite to try and prove that quasars were clustered around nearby galaxies. And this is his experience, where he worked and what he did. So in the 50s, he worked at Caltech Mount Wilson, mentored by Hubble and working on Seyfert variables and M31. In 66, he went to Palomar, published the Atlas of Peculiar Galaxies. In the 1970s, he was at Palomar Observatory, identifying bridges between high and low redshift objects. There are many. In 1983, 2000 to 2013, he was at Max Planck researching intrinsic non-cosmological redshifts in exile. He inherited Hubble's skeptical approach to grand cosmological theories, and I'll touch on Hubble at the end, and his intense focus on observational evidence over mathematical models. It is deeply ironic that the man who would later try to dismantle the Hubble law, the idea that redshift equals distance, was trained by Hubble himself. Don't you think? I do. He wrote several books for a general audience detailing his struggle against the Big Bang establishment. Forced to resign from the Carnegie Institute of Washington observatories after the Caltech head threatened him, saying, "Unless you change your line of research, we will take your telescope time away." And this is his papers. They can be found at www.haltonarp.com. If anybody wants to go there and read his papers, feel free. First one is intrinsic redshifts in quasars and galaxies. Next one is high redshift galaxies to the blue Pacific. I don't know what that means, but quasars and galaxies, gamma ray and bursters, and fingers of God in an expanding universe. Those are his papers. Some of them. Here's another little bit. Is physics changing? Origins of quasars and galaxy clusters. The observational impetus for Lesage gravity. A symposium on active galactic nuclei. And a couple of more papers, research with Fred. I don't know who that is, and then rebuttals from
audio input.
And these are Halton Arp's books. The Redshift Controversy in 73. Quasar redshifts and controversies in 87. Seeing redshifts, cosmology and academic science.
Seeing red.
Seeing red.
That's available online. That's a very good book.
Yep, you can download that. Most of these books, you can probably find them in PDF form. A catalog of discordant redshift associations, a catalog of southern peculiar galaxies and associations with Barry F. Medor. And here's Halton Arp himself. And one of his books is Catalogs of Discordant Redshift Associations. Here's an interesting object, NGC 7603, with a absolutely undeniable physical bridge between this object, which is a quasar, which is, they quantify it as a quasar, and these two little dots here and here within the stream of plasma itself, and they're quasars as well, and they have redshifts that are high when they're first born, and they go lower as they get further away from the galaxy as they get older, and they get even older or lower as they get even further away. At some point, this will grow and get larger and older, and it will match the redshift or get even closer to the redshift of NGC 7603. And here's NGC 4319 with another obvious bridge to Mercurian 205. It's undeniable. You can see it in the radar, in the radio images. You can even see it in the optical. It's undeniable, in my view. And I'm guessing this is his later work, where he's identifying quasars along the axes of galaxies, active nuclei of galaxies, in other words, Seifert galaxies. And he's plotting the redshifts, and you can see as they're high, as they're being newly ejected, and as they get further away from the galaxy and older and drawing, getting bigger and growing, their redshift lowers and drops. And there's a whole bunch of these. There's a plot. There's a whole bunch of these, and I'll show you that in a few minutes. The conclusion is that many colleagues defended him to no avail, and many of them agreed with his conclusions that some redshifts are inherent, not due to distance and velocity. Here are a few big names and highly respected cosmologists that liked his work: Margaret Burbidge, her husband Geoffrey Burbidge, Sir Fred Hoyle, Jack Solanek, who saw the original non-doctored images of which I can't remember which galaxy. I think it was the one that was connected to Mercurian 205, NGC 4319, and Martin Lopez Cordania, who with his partner confirmed ARP's work on some galaxies. John Dobson. It's not a question for debate that, in fact, some quasars are physically connected to lower redshifted objects, galaxies. The mainstream will point to those doctored images and say, see, he was wrong, and we are right. Like they always do. The centers of galaxies are where creation is taking place, not some Big Bang billions of years ago. Geoffrey Burbidge quote. What's really happening in these systems is that the centers of galaxies are where creation is taking place rather than just in a Big Bang. And so you're looking at all the mini bangs where matter and energy are literally being created. The Armenian astronomer Victor Bartsinian postulated that the galactic centers was where creation was taking place. And that, my friends, is the end of the presentation part. Let me drop this down. And here's a bunch of ARP's own quotes. If you
they're
want,
real tiny.
Yep. I won't bother with them, but they can be found. There's a bunch of PDFs of all of his work. There's tons and tons of information on Halton ARP, and if you went and looked at it, I think you would change your views of redshift entirely.
I'm not really sure there's anybody here that really maintains the mainstream position, is there? At least not in our group.
Right. Well, Halton ARP is the proof that everybody's been looking for a non-Big Bang cosmological redshift.
He argued that, yes.
Yeah.
He's not the only one, of course.
No, there's been a few.
He's probably the most prominent in terms of them essentially forcing him out of the mainstream is kind of a sort of a primary example of their resistance to doing actual science.
Right. Well, I mean,
okay, I'm sorry I interrupted your presentation.
Oh, that's all right. We got lots of time.
Do you have any more here to talk about? Do you have some pictures, or the pictures are pretty impressive?
Well, they're all on his papers. All of those pictures are all on his papers. If you go to his website, haltonarp.com, you can find them there. It's all there.
Rick, can I ask a question here?
Sure, James, go ahead.
What I'm understanding is that you're saying, based on ARP's work, that physical objects like these galaxies or quasars or whatever they are located very close to each other, but with respect to the gigantic distances in the universe, located close to each other and yet have different redshifts. Is that what ARP is actually saying here?
Yes. He's saying that these quasars are actually associated with the galaxy. They exist on the axes of the galaxies that they were birthed out of, and the mainstream see these quasars as being billions and billions and billions of light years in the background of these objects, of these galaxies that are.
So you're saying that they're not really spatially juxtaposed.
Yeah, they're many billions of light years away from this galaxy that you're looking at. That's what they're saying. And Halton is saying no. Based on their redshift and the quantization of that redshift, where it looks like these objects' redshifts are changing, are lowering as they're getting older and further away from the galaxy. And there's many instances of that phenomena on many galaxies, too many to be coincidence. One or two, you could see that being a coincidence, but there's hundreds of these galaxies that he's mapped that have that same system where redshifts are high, close to the galaxy that birthed it, and as they go away further and further, they're lower and lower redshifts. Too many of them to be coincidence. But okay, as I was going to say, ARP is called the Galileo of Palomar. He is the Galileo of modern astronomy, and for good reason. Chandrasekhar said he had no imagination to think that this was happening. Well, if you can't have an imagination and you're in a position like that, and you're not prepared to question the current model, why are you even there, is my question. Go and do something else if you're not open-minded. Anyhow, that's me ranting.
Well, there's nothing that says science is about being open-minded. Science is about conforming to the established knowledge base.
True enough. True enough. I'm going to go to my phone here and bring up some information about what Edwin Hubble thought about the Big Bang. In his later years, Edwin Hubble remains highly skeptical that redshift of galaxies was caused by true expansion of the universe. While he provided the observational evidence that led to Hubble's law, the father of galaxies that have greater redshifts, that further galaxies have greater redshifts, he consistently referred to this phenomena as apparent velocity rather than actual physical recession. So those are the words of Edwin Hubble himself. He did not believe that redshift was caused by distance and velocity away from us. He probably was looking at Arp's work and agreeing with him. But anyways, that's just speculation on my part. All right, well, I'm going to bring up a couple of videos, 3 videos, and enjoy.
Okay, we only have like 15 minutes.
We only have 15 minutes. This one's only 7 minutes long, so I'll play this one.
All right.
Take a couple of questions, and then we'll play the other 2 at the beginning of the next one.
On December 28th, 2013, the acclaimed astronomer Halton
The volume is
the audios.
86 in his home in Munich, Germany.
Is that better?
Art posed a challenge to the very foundations of modern cosmology. A challenge that only grows more relevant with new, astonishing discoveries. We present Wal Thornhill as we honor Arp's remarkable contributions to science and astronomy.
I was first introduced to Halton Arp's work by Mel and Amy Aitchison after one of our very first meetings in Portland, Oregon. They could see the relevance of Arp's discoveries to the electric universe that I was then presenting. That was in the mid-90s. In September 2000, I had my first meeting with Halton Arp in Portland, once again at one of the Electric Universe meetings. And it was quite a historic meeting because of the other people who were there, in particular Tony Peratt, who is known for his groundbreaking work in plasma cosmology. And the input from both of these people to the Electric Universe has been considerable. It was only a month later in October that I actually shared the stage in London with Halton Arp. Unfortunately, he was busy at the time, involved with a filmmaker making the documentary The Cosmology Quest, which is now available on DVD. Halton...
I'll be showing a piece of that Cosmology Quest video, by the way.
Known as Chip Arp, was a professional astronomer who, earlier in his career, conducted Edwin Hubble's nova search in M31. He earned the Helen B. Warner Prize, the Newcomb Cleveland Award, and the Alexander von Humboldt Senior Scientist Award. For 28 years, he was staff astronomer at the Mount Palomar and Mount Wilson observatories. While there, he produced his well-known catalogue of peculiar galaxies that are disturbed or irregular in appearance. Arp discovered that many pairs of quasars with extremely high redshift values are physically connected to galaxies that have low redshift and are known to be relatively close by. Yet according to the Big Bang expanding universe, the high redshift quasars must be located far behind the nearby galaxy. Because of Arp's observations, the assumption that high redshift objects have to be very far away, on which the Big Bang theory and all of accepted cosmology is based, has to be fundamentally re-examined.
While mainstream cosmology has come to embrace the story of the Big Bang and the expanding universe, cosmologist Carl Sagan noted the challenge that Halton Arp's discoveries pose to the standard theory. In his 1980 bestseller Cosmos, Sagan wrote, "There is nevertheless a nagging suspicion among some astronomers that all may not be right with a deduction from the redshift of galaxies via the Doppler effect that the universe is expanding. The astronomer Halton Arp has found enigmatic and disturbing cases where a galaxy and a quasar, or a pair of galaxies that are in apparent physical association, have very different redshifts. However, some believe that institutional science's response to Arp's challenge is a disturbing example of political suppression."
Arp's life story exemplifies everything that's wrong with modern showbiz science. His paper, Companion Galaxies on the Ends of Spiral Arms, which offered a fundamental challenge to Big Bang cosmology, had Subramanian Chandrasekhar scrawl across the top corner, "This exceeds my imagination." That may have been so, given Chandrasekhar and those like him had a great deal to lose, but it was not a scientific reason for rejection of Arp's observations. However, Arp's telescope time was curtailed and he was forced to continue his research in Germany. Halton Arp has been dubbed a modern Galileo because other scientists refuse to see what is obvious even to amateur astronomers, that low redshift galaxies are often found connected to high redshift companions. Clearly, most of the redshift is intrinsic to the companions. At a single stroke, Arp removed the foundation for Big Bang cosmology. He had in fact proven Edwin Hubble, his mentor, correct, for Hubble had written in the Royal Astronomical Society monthly notices in 1937, and I quote, "If the redshifts are a Doppler shift, the observations as they stand lead to the anomaly of a closed universe, curiously small and dense, and it may be added, suspiciously young. On the other hand, if redshifts are not Doppler effects, these anomalies disappear and the region observed appears as a small, homogeneous, but insignificant portion of a universe extended indefinitely both in space and time." End of quote. The irony is that the constant defining the hypothetical rate of expansion of the universe bears Hubble's name. The winners rewrite history. Arp proved Hubble right. We live in a universe extended indefinitely both in space and time. Halton Arp believed in the scientific approach more strongly, it seems, than do mainstream scientists. Arp notes that his opponents invariably stated that, and I quote, "The observations cannot be accepted because there's no theory to explain them." End of quote. Of course, the companion statement was always, and I quote again, "There is no need to modify conventional theories because there are no valid observations which contradict them." Clearly, these two statements have always provided the perfect double bind against progress in the subject. Arp has had dramatic confirmation, which involved also Sir Fred Hoyle, Geoffrey and Margaret Burbage, and J.O. Nalika. And he says, with one object, NGC 3516, we had confirmed 1, the alignment of quasars along the minor axis, that is the spin axis of the parent galaxy. 2, the decay of the redshift and increase of luminosity as the quasars travelled outward. 3, their evolution into companion galaxies. And 4, and very important, the quantization of the evolving redshift steps.
Right there, they confirmed Arp's work that quasars were being birthed out of active galaxy nuclei, Seyfert galaxies, and that as they went further and further out, their redshift lowered and lowered, and then they turned into galaxies themselves.
Arp writes, "Since science is supposed to be characterized by successful prediction, it is significant to note that this most important single observation of quasars being ejected from an active low redshift galaxy was rejected without ever being sent to a referee by that leading journal of trustworthy and important results, Nature magazine." Arp also writes, "The most influential people in the field, in their jovial camaraderie, would simply ridicule anyone who had reported discordant results. How can one fight rumour? I think the
gatekeepers.
The only answer is that one must fundamentally change the structure of academic science. Communication must be directly to fellow researchers and the public with no chance of censorship. The cancelling of Arp's telescope time and the suppression of all discovery mode programs is a testimony to the extreme fear that the opposing side has of this kind of research, that they would ruthlessly seek out and subdue this small effort. On the other hand, it raises the question of whether the enormous financial, engineering and administrative effort put into astronomical research today is being wasted at the point of application by scientists who believe they already know all of the important answers.
Yeah.
That it?
Well, I got 2 more videos, but time is running low, so I'll take some questions.
We've already got the warning. So, okay, any comments or questions here before we close out this segment? Jim, do you have any?
Ido here, just a short comment. This work that's presented here by Holt and Arp is one of the key pieces of information for me that makes it tangible to really pay attention to what's being said here, in contrast to the Big Bang, of course. I find it very convincing and worthy of a lot more research, I would argue. That's all.
Agreed.
Well, it kind of turns everything they've been working on for years and years on its head, which is why they don't want to acknowledge it. Because it really pretty much invalidates the whole what's in the textbooks and their whole paradigm. You know, the paradigm of there was a Big Bang that created a bunch of hydrogen. The hydrogen condensed to form stars. The stars, the protostars or the early stars, then had nuclear reactions in them that created lithium and carbon and elements on up the scale to iron. And then you had supernova explosions, which then ejected the heavier elements out into space. And then they condensed to form stars, and you repeat the process. And this is their paradigm. And the whole idea of what ARP is presenting is essentially contrary to the whole everything that they've developed as a theory for the origin of the universe and the creation of the elements and stars and planets.
Well, you can equate it to biological reproduction, where this galaxy is giving birth to these quasars, and these quasars are growing up over time into galaxies themselves, and then perhaps turning into Seyferts and giving birth to other quasars. It may have all started...
That's a non-scientific.
Damn, it takes me a long time. I would put forth that everything has to die, even planets, solar systems, galaxies. Although you don't see too many dead galaxies. Unless you have it. I don't know, at some point, I don't know, we'll have to see, but I think everything that lives in this plane has to die sooner or later.
Scientific concept as far as the mainstream is concerned, although their ideas are pretty non-scientific too.
Right. Well, that may be exactly what's happening, though. That may exactly be what's going on in this universe. That it may have started with one galaxy, and birthing and birthing and birthing and making new galaxies and expanding out that way. Expansion may be happening, but not in the way that a Big Bang expansion happened.
In support of that, Rick, nature, and very scientific, by the way, is filled with examples that you need something in order to create something. The cell membrane is an example. You need a cell with a cell membrane in order to create a cell with a cell membrane. You can't create a cell membrane from the get-go. Same is true with the chicken and the egg, right? Which came first? The nucleus or the atoms or the elements may be a similar thing. In order to create, between brackets, the neutrons, you already need existing neutrons and an existing nucleus to create more nuclei. So the concept here of, on a larger scale, of galaxies giving, between brackets, birth to another one, I find actually, still scientific and quite an interesting concept.
Right, I agree. It's more natural than we think space is. Electricity and plasma behave like biological systems. That's why plasma was coined plasma by Irving Langmuir because it acted like blood plasma. It acted like a biological system. It did things that are done by biology. So he coined the phrase plasma.
My point that I was making is that this mainstream community resists the idea of an analogy between physics and biology because they're on top and biologists are down below the physicists in the hierarchy of science. And I don't think they want to admit that biology has anything to contribute to physics. I think that's really what the issue is.
That's part of the problem, is that they separate themselves into cells. This science and that science and the other science, and they don't even talk to each other.
Right.
And that's the problem.
We're coming up to the end here. That's Charles Lucas's silo theory. I don't know if you're familiar with Charles Lucas.
No,
unfortunately, we haven't heard from him in several years, and we don't really know much whether about his health. Apparently, is in trouble, and Dennis Allen apparently. I don't know that anybody's been in contact with him, but anyway, he used to talk a lot about that when he was active in the CMPS.
No, I'm not familiar with him. Sorry, no.
Okay, well, another person who used to engage in our Saturday morning conversations that has faded into memory, and we're not really sure whether.
Who used to appear on the Saturday shows and is no longer around.
Charles Lucas.
Yeah, but you said there was another person as well as that, no?
Dennis Allen, I mentioned.
Yeah, no, he's still around.
Charles Lucas used to. The point I was making there is Charles Lucas really emphasized that point, which he called the different silos of science. And he used to come on Saturday mornings and talk about that very consistently. That was one of his major points that he made. And I'm surprised that you don't remember Charles Lucas. Does anybody here remember Charles Lucas?
Of course I remember him, yes. I've been in contact with him as well. He's written these books, The Universe.
Right. And I've been sort of hammering on people I'm sort of, Dennis Allen has reported that he was in an automobile accident, but that was several years ago, and we haven't heard from him since then. And so I don't know what happened to him. There's other people who are like that were active in the CMPS and the dissident community, and they just kind of faded away and disappeared. And we don't really know what happened to them. It's kind of strange. So I guess.
Have you got any other names?
Excuse me?
That's what I'm wondering.
I was looking at a book the other day by Al McDonald.
Oh, yeah.
And I went on the internet. He wrote this book, Uncommon Knowledge, which I have a copy of. And I was looking through my library, through the bookshelf, and I came across this book, and I thought, I haven't seen this book in a while or thought much about it. And, and I was thinking about doing a presentation about his book. And then I went on the internet and I tried to figure out what happened to him. And I did a search. Is he alive? Is he dead? No, I couldn't really find any obituaries or anything. He just kind of disappeared,
I think he was more involved in Glenn Baxter's group. I don't think he ever got really involved with the NPA. as far as I
That
recall.
could be. I know that. I know that that's how I got associated with him was through Baxter, Glenn Baxter, who unfortunately died of cancer, and that's kind of a unfortunate. And we're losing these people, and we don't know what happens to them. So I'm sorry to interrupt on your presentation.
Well, no worries, no worries. It's all good.
I did want to point out a little bit before you proceed further that I've read a number of these papers, and one of the things that he did was he spent a lot of time doing the mathematics of showing that these associations that you're referring to were not likely to happen by chance. He did these statistical studies of given a distribution of a random distribution of quasars across the sky, that it was not probable, that it was highly improbable that these quasars could be associated with galaxies.
As I mentioned earlier.
By accident. In other words, he showed mathematically
by chance
that the chance probability of these associations occurring by accident or random chance was extremely low. And of course, that was not accepted by the mainstream. They rejected that. It's kind of interesting. They like to use probability when it supports their argument, but when it doesn't, then they don't accept it.
Almost impossible alignments.
Correct.
I mean, there are too many of these galaxies, these Seyfert galaxies with quasars being ejected out of them, to be coincidental. Like I said, it's just almost an impossibility that this structure around a Seyfert galaxy is chance. Anyways, as you can see, some of these images, they're offset of the exact center of the axis of the galaxies that they were ejected out of. That leads me to believe that it's shaped like a cone. The Birkeland current is cone shape as it pinches into the galaxy, and when a quasar is ejected, it follows along one of those edges of the cone.
So you're saying it's nutating?
It's what?
There's a term called nutation, where the axis of a top goes around in a circle, creating. Well, it's called nutation. I think, if I'm correct.
Okay, I didn't know that term. But that's what we see in the Earth. We see that in the Earth with its magnetic field. We see that now. I pointed it out in my last video that the last couple of probes that they sent to the north and southern poles of the sun are seeing these spiraling, expanding spirals in the northern and southern poles of the sun. And this is what we're seeing as well with these quasars. We're seeing that exact same phenomena, but on a larger scale, a Birkeland current that is feeding this galaxy in the center here. Okay, moving
May
on.
I ask a question? Obviously, these observations are something that mainline science cannot deal with. It's outside their ken. But am I not correct in assuming that ARP didn't counter the contention that there was a redshift, say in a galaxy without these quasars attached, or indeed in the galaxy itself, and that redshift did in some way increase with increasing distance away? And if that is so, and he didn't contest that, he presumably did contest the Doppler explanation of that. But was it within his ken to conceive of a sort of, a tired light, an energy dissipation being the primary cause of that redshift?
I haven't seen anywhere in his work that I've been exposed to where he talks about a tired light.
Well, I gotta say it. He sent a paper to the journal, the publisher at their Mecca of Meccas. Why you'd make a magazine or Mecca? I can't remember the name of it now. But it's some big name. A lot of you know the name. I'm just drawing a blank. But he wrote a paper, and his paper was rejected. And that's when that Zankloff guy, I don't know if the same guy that played Woodstock or not, I don't think so, but he wrote, this exceeds my imagination. Well, all basically he was saying in it is that groups of quasars have been noticed with different redshifts attached to the same shit. So, okay, let me fix that. Was connected to the same filament that the galaxy was connected to. And they said, oh, that's impossible. And they even went as far as faking one. And if you watch the cosmology class, which I'm going to play next, seeing as how we're here, we're going to watch it in real time. And then next week, I hope to have my Saturn video together. That's my sincere plan. So I have a whole week to work on it. As long as there are no more catastrophes, I should be okay. I'm lucky to be here, man. Let me tell you. You know what? And I wasn't scared. That's the thing. Something comes from somewhere and gives you strength. Because I thought I was gonna go. Blood's pouring out of my mouth, the faucet, and the doctor, or the EMS guy, she looks like he popped a carotid artery. And I said, am I gonna die? And he said, nope, we're gonna get you to the hospital. But lucky for me, about a third of the way there, it stopped bleeding. And it stopped bleeding all the way till I got to the emergency room. Now, whether it was the hand of God or what it was, I don't know. But then it started bleeding profusely again. And the next thing I remember, I woke up 3 days later. I don't know what they did to me. They said they grazed the hole, but they had to find it first. And then in the meantime, they're pumping blood into me. My heart stopped. They had to do CPR. There was enough time for the nurse to call my son and tell him your dad has passed. For him to walk up to ICU room 3 and say, hear the doctor say, I got him. That, so however long that took is how long I was out. And that's, I don't remember, no flashing lights or anything, but then again, it wasn't on that long. But, man, what a hairy time. But it makes me view death differently now. Maybe, I don't know, I hate to say it, but maybe it needed to happen, because I was just so afraid. But anyways, let's get on with the next show. It's only 40 minutes long, and then we'll move on. This is right in the same alley. It is, where would it be? where are you? No? Right here. Yeah, you like this. This is good. And Rick was good too. My hat's off to him. He did a really good job.
In the beginning was the Big Bang. We are told that 13 to 20 billion years ago, everything that makes up the universe as we know it was spontaneously created out of nothing through an unimaginably violent explosion. But did it really happen as we are told? A growing number of astronomers doubt it and are showing why. This is their story, the story of the universe.
The observational aspects of trying to understand the universe, I think it's reasonable to start about 100 years ago. And about 100 years ago, almost everybody in astronomy, without question, assumed that the whole of the universe was what you could see in the Milky Way. Nobody felt that the universe was any bigger than the stars that you see in the sky, associated with our own local Milky Way. And that was the situation certainly around 1905, times like that. There are well-known people who propounded these ideas. 10 years later, Einstein first proposed his general theory of relativity. Now, when Einstein proposed this, it's a theory of gravity, which means that it's a theory which should represent the whole of the universe, because it's gravitational forces that are.
Did you ever notice everything is always changing? Nothing stays the same.
Are controlling the universe. Well, Einstein made this theory around 1915, and he immediately wanted to try and use this theory to explain the universe as it then was, the so-called Milky Way system. But of course, the idea of this was that it was a static system. That is, it wasn't contracting or expanding, it was a static system. And Einstein found that his equations did not allow for a static universe unless he inserted a certain constant in the mathematics, which became known as the cosmological constant. But what happened in the early 1920s was that a very clever Russian called Friedman in 1922 found solutions to Einstein's equations which allow the universe to either expand or contract. Now that was done in the Soviet Union soon after the revolution, and nobody in the West knew about this, I think. But in 1927, a Belgian priest, the Abbé Lemaitre, as he later became, also discovered these solutions. And he went to England, and his work was publicized in Cambridge and elsewhere, and the famous English astronomer Sir Arthur Eddington and others got to know about this, and they immediately began to say, how can this apply to the current universe? Well, in the same period, in 1929, Hubble made what I still believe was the most important discovery in extragalactic astronomy in the last century, or the last century but one. He showed that if you look at the spiral nebulae, the faint spiral nebulae, the shifts in their spectra are proportional to their apparent brightnesses. And this led very soon to the idea that this fitted very well with the expanding universe, and that indeed this is the kind of universe we lived in, that what we were looking at are galaxies, Milky Ways, further and further away from us, and the further away from us, the larger the redshifts, and if that's interpreted in the way that most people would interpret it, this means that they are moving away faster and faster. So this was the original idea. By the 1930s, the front page of the New York Times said we live in an expanding universe.
His great discovery, it was for galaxies like our own Milky Way galaxy, and they all followed the same rule, that the fainter they are, the larger their redshift. In other words, the faster they are moving away from us. This is known as the Hubble law, and directly led to the expanding universe theories. But in the 1960s, there was a new discovery: the quasi-stellar objects, often referred to as quasars. They appear as star-like points on the sky, frequently blue in color, and they have very, very large redshifts, implying that they are at huge distances from the Earth, at the very boundaries of the observable universe. Some astronomers soon found that a vast number of these strange new objects populated the regions around spiral galaxies, and were not only observable with radio telescopes, but were optical and X-ray sources as well. There were two properties of the quasars that were difficult for astronomers to understand using the expanding universe theory. The first was that if one plotted their apparent brightness against their redshifts, as one does for galaxies, one gets an unexpected scatter on the diagram, instead of the smooth curve made by the same plot done for galaxies. This seems to indicate that the quasars do not follow the Hubble law as do most other objects, and that there is no direct indication that they are actually at their proposed redshift distances. In fact, it is argued that if Hubble had first been given the plots for quasars, he and other astronomers would never have concluded that the universe was expanding. The second property was that quasars are very small, compact objects, sometimes only a light year across. So if quasars are really at their extreme redshift distances, they must then be the brightest and most energetic objects known to astronomers. So energetic, in fact, that untestable, almost metaphysical mechanisms must be applied to explain the phenomena. On the other hand, when placed at their observed distances, that is, in the neighborhood of nearby galaxies, their brightness and energies become normal, and no special mechanisms need to be evoked. This problem has led many astronomers to abandon the idea that all redshifts are due to their speed of recession away from the Earth. And if this is true, then there is no need for an expanding universe, and the Big Bang never happened. The questions arise. Is there a connection between certain types of galaxies and the quasar? Are quasars ejected from galaxies, and in fact proto-galaxies themselves? Is there some other astrophysical process which can explain the redshift discrepancies? One of the world's most controversial experts on the structure and morphology of quasars, Halton C. Arp, has for 35 years proposed just such an idea. For the heresy of opposing orthodox interpretations of the redshift problem, Arp has had to pay a heavy price, the same price paid by many a scientist with new and innovative ideas. Dr. Arp was forced to resign from his permanent position at the Carnegie Institute of Washington Observatories, after the Caltech head of the Telescope Allocation Committee threatened him by saying, unless he changed his line of research, they would take away his telescope time. Due to this fact and his ongoing struggle against the established paradigms, ARP is often referred to as the modern Galileo.
I remember when I sent the paper into, the first paper into Astrophysical Journal on the nature of companion galaxies, and I had a lot of them on the ends of spiral arms, so I was sure that they were connected, and I showed that they were systematically redshifted. I sent that in with naive, great expectations that people would be terribly interested and impressed on this. And the editor of the Astrophysical Journal at that time was Subrahmanyan Chandrasekhar, who had a fantastic reputation as a master theoretician and also quite an incomprehensible theoretician, and a tremendously powerful figure in the field, and editor of the Astrophysical Journal, which was probably the most powerful position in the field. And he chose not to, in his wisdom and judicial fairness, chose not to send it to a referee, but he just wrote across the paper, "This exceeds my imagination," and he sent it back to the director of my institute, Horace Babcock, with the obvious implication, you've got to do something about this staff member of yours who's doing these very bad things. And so Horace called me down in the office one day after this, and I walked in his office, into the director's office, and I saw this paper lying in front of him with Chandrasekhar's scroll across it. And Horace looked at me and said, "Well," he said, "this is just too much, and you're going to have to start looking for another job." And so all I could say to him was, "Well, if you send me that in writing, please send me in writing." And I was waiting in great trepidation for weeks and months to get something in writing, and I finally never did, so I realized that he decided to give me another chance, so to speak. So that was fairly early in the game, and then some years went by, and there was the competition for time, particularly on the 200-inch telescope, was getting more and more heated, and people were saying, well, we can't continue to give time to this obviously incorrect and embarrassing research that ARP does. So finally they sent a letter to me from the allocation committee, including a number of the younger members of my institute, saying that unless I changed my line of research, that they would have to take away my telescope time. At that point, I considered the situation very carefully, and I figured that the evidence, although a lot more evidence could be gathered and has since been gathered since then, the important thing was not the evidence, because if it was true, it would come out someday. The important thing was the principle of scientific investigation, whether scientists could follow new lines of investigation and follow up on evidence which apparently contradicted the current theorems and the current paradigms. And I also felt that regardless of what happened to me personally, that this was the important issue, and that I had no choice but to resign on the point of this issue, so that if it developed, which I thought it would, that my line of investigation was correct, that people then in the future would say, okay, this was the wrong thing to do, and in the future we're going to have to see that this kind of thing doesn't happen again.
Observers come in now with the belief that we live in a Big Bang universe, and therefore all of their ways of understanding things are tailored to that. And they don't come in with the possibility that our alternative, or any other for that matter, is right, and really do it in an open-minded way. And of course, what goes along with that is that observers who would like to test this way find it very hard to get observing time and so on. I mean, this relates to the whole issue of whether the complete lack of balance in the way the observational programs and the funding are conducted. There's no question about that. I don't think that anybody would argue about it.
I've always said that the cause of the troubles is the American graduate school. You get one person who then lectures to his students in graduate class, and because you have a system, you see, when we had graduated first degree, we were independent. We could thumb our noses at the professor. And in fact, the best way to get ahead was to do something that the older people didn't agree with. Right. That was the way to do it. And but in the graduate school, you all have to learn what you're taught, what the professors are teaching you, and then those people go out and get jobs, and they have another graduate, their own graduate school, and it just tier after tier. You get a few places like Caltech or like Harvard, and they set the fashion for every place.
I think there's a problem with graduate education. I think graduate education is not teaching students to think, to be independent researchers. I think it's teaching them to be part of a scientific society. And too much, especially students that are at the so-called elite institutions, I think they're taught too much the paradigm of their advisor.
All of us, whether or not we served in uniform, are veterans of a war in which freedom and free government are at stake. Such fullness of knowledge is the direct function of education. Most of us work hard to provide our homes with every possible comfort for our children. We safeguard their health. We strive to set before them good examples of moral living, of manners and deportment. Possibly we even pamper them. Yet complacently, even carelessly, we commit our children to schools of which we know but little. We cannot meet the complexities of modern life with outmoded school systems. We must keep our educational standards abreast of the swift-moving times in which we live, if we hope to preserve our national heritage and our American way of life, the American way.
When I was director of the National Observatory 20 years ago, there was a very well-known astronomer now. In fact, she's just won the Cosmology Prize. That's Vera Rubin. She was carrying out a program at Kitt Peak at the National Observatory of observing faint spiral galaxies with a view to looking to their redshift distribution, their velocity distribution. And this was a program that everybody thought was a good program. And so she'd been given observing time, and at the end of about a year, she had completed about a third of her program. And so she actually wrote a little paper pointing out that she was getting results very different from the ones that were expected. And we had our usual meeting, and when we got to her program, which was an ongoing program, so people just looked it over, the leading extragalactic astronomer on my committee of that day immediately said, well, look, she's getting this result. It doesn't fit. It has to be wrong. I recommend that we stop the program. That was his position. And what was interesting to me was I sat there and listened to this discussion. And the majority of the people, because of his level of knowledge and authority, went along with him. So the recommendation of the committee was that we stop the program. Well, I had the last word, so I ignored it. But most people don't. And the peer review system and NASA itself, which is very conformist, will always do just that. That's one of the reasons why the road ahead is hammered out. As Hoyle said, anytime you point a new telescope at the sky now, you're only going to find what you already know is up there.
I have a lot of trouble with the academic world, the same as I do with the Bible Belt. That's the same kind of trouble. It's the same kind of trouble. It's because they get a picture of this world which they are sure is right.
Yes, yes.
And they hang on to it for all they're worth. But you know, I often point out that I am probably more unorthodox than anyone who has ever burned at the stake. It's illegal now.
Illegal burning.
It's illegal now to burn somebody to the stake in your backyard.
Peculiar galaxy NGC 7603, discovered 30 years ago by Halton Arp, is one of the more striking examples of galaxy-quasar connections. It has recently been re-examined after the discovery of 2 new quasar-type objects embedded in the connecting filament. The renowned optical astronomer Margaret Burbidge has for decades been a central figure in the struggle to bring controversial observations such as NGC 7603 to the attention of conventional astronomers. And for her fairness and untiring efforts in the field, she has become one of the most widely respected women in astronomy.
There's a very interesting galaxy known as NGC 7603. It's a Seyfert galaxy. That means it has one of these active nuclei with strong emission lines and a lot of activity, obviously, going on in its center. And it was studied years ago by Chip Arp in his Atlas of Peculiar Galaxies. It has a spiral arm that seems to come right outside of the galaxy, trailing right out, and it ends up on a fainter galaxy, but it ends right up, so it's connected the nuclei of the 2 galaxies.
In the Atlas of Peculiar Galaxies, which was published in 1966, that was the point of the atlas, and one of the objects, just to illustrate what a peculiar galaxy is this what is now famous NGC 7603, and this is the central Seyfert, which means just a very, very active galaxy with a lot of energy in the nucleus and a lot of explosive energy and so forth. And here's the high redshift companion here, and you see it's joined by a filament of material. It turns out, from the observations, that this filament of material is material of the galaxy, gas and dust and stars and so forth. It's been drawn out in the ejection. But the astonishing thing, the controversial matter, is that this galaxy is a much higher redshift than this.
Now, NGC 7603 has one redshift of about 8,000 kilometers a second, and the other galaxy has a much larger redshift. So how can they be connected? Well, these data were published years ago, and everybody said, well, this is just a chance location of a background galaxy near an interesting foreground galaxy. And that spiral arm has nothing to do with it. It's just the whole thing is just a chance.
If you see 2 objects close together with very different redshifts, you only have one of 2 explanations. One is, as I say, that a large part of the redshift has nothing to do with distance, and the other is that it's an accident. So the real issue that you come down to is how frequently do you expect to see accidents?
If you look carefully at the pictures that were taken of this field, you will notice 2 faint stellar objects that are in that spiral arm. One is close to NGC 7603, and the other one is close to the faint companion galaxy.
In the year 2001, when the 2 young Spanish astronomers worked on this with the Las Palmas telescope, they saw that there were these 2 condensations, stellar condensations. They looked like quasars, but everybody would have said that they had to have the same redshift as the central galaxy because they were obviously in this filament that had been ejected. What they found was that each of these objects had a much higher redshift, and that the filament itself had the same redshift and spectral composition as the galaxy from which it was ejected.
And they got some spectra using what's called the Nordic Optical Telescope in the Canary Islands on La Palma. It's not a very large telescope, but they got some excellent data. And they got spectra of these two faint objects, one by 7603 and one by the companion galaxy. And believe it or not, they showed that both of them were quasars. Not very high redshift quasars, but definite quasars.
Fairly big blow up. It's a couple of months I think across. But it looks like it's extended.
Anyway, it looks very.
So we'll go ahead and move it and narrow it up.
Chance to have many quasars around a galaxy as a background objects. Of course, you have some chance, but these are very, very low, and this is what should be answered. This is what should be answered. NGC 7603 is a very special case of this correlation. You find not only three objects with different redshifts in the neighborhood of a major safer galaxy. You also find the filament connecting all of them. So this is more important because the probability to have all these objects, not only in the neighborhood, but exactly in the filament is extremely low.
The galaxy, which is an active galaxy, two low redshift quasars, and another galaxy with twice the redshifts. In other words, you had four objects all connected together, apparently by a luminosity, by a luminous bridge, each with a different redshift. Now that, I would say, is pretty conclusive evidence for the existence of non-cosmology redshifts.
We were lucky because we have found that the object has more controversy than expected. If in the past Chip had thought, Barbies and all other people that have dedicated some effort to research this object, if they thought that there were two objects connected by a filament with different redshift, now we have discovered that there are four objects all connected by the same filament and all of them with very different redshifts. So the Doppler redshift is discovered.
I think they have to look at it, and I think it's one of the most striking results that we have available. How they can make sense of it other than saying that these objects, that these redshifts of connected objects that are the same, more or less the same distance from us, that these redshifts have non-cosmological components to them.
The topic of the nominal redshift is very important for most of the areas related with cosmology and extragalactic astronomy nowadays. If we assume, as it is done nowadays, that all the redshift are pointing the distance of the galaxy or the quasar or whatever, of course the results will be very different than assuming the other thing, that the redshift are due to other reasons. The distance of the quasars and the galaxies will be different, the energies involved in the process will be very different, so a lot of astrophysical processes will have to change.
Conclusive evidence that the expanding universe was not correct, and that the redshift distance law was not correct, and that we had to have some way of creating new galaxies with high redshifts.
It is normally argued that the Big Bang, for instance, the Big Bang cosmology is against the anomalous redshift question. And of course, the Big Bang theory is the most important theory that we have nowadays to explain all that we know about cosmology, which is not too much, in my opinion.
There's a large body of work going on, observational work, theoretical work, which is based on the assumption that quasars are at their cosmological distances. If it turns out seriously that we're right, then all that work is in vain. We don't know anything like as much as we think we do by saying that the quasars are far away. And that's another huge problem for people to face up to.
One of the frightening things, I think, for conventional astronomers is to accept the fact or to realize that these intrinsic redshifts for the quasars and peculiar galaxies and so on, active galaxies, means that a lot of the things which we thought were out at great distance in the universe are very much closer in. And in fact, you would have to say that what we call the local supercluster is much more crowded and contains many more objects than we previously thought. And then the question comes up, well, what is out beyond the local supercluster? And can we with any certainty identify any objects that are out there?
Aware of what of our interpretation, because we cannot distinguish which objects have cosmological redshift and which objects have non-cosmological redshift. Then we cannot trust the redshift indicator as a distance indicator.
People who work on the origin of the universe, they ought to look at data of this sort, because they've got to understand this. And I've heard good friend astronomers say, well, there's more out there in the universe than we understand.
What's really happening in these systems is that the centers of the galaxies are the places where creation is taking place rather than just in a big bang. And so you're looking at all these mini bangs where matter and energy are actually literally being created. And this is an old idea which is not ours. Originally, it was due to the very famous Armenian astronomer Victor Ambatsumian, who only died a few years ago, who also argued that galaxies which appear to be coming apart and objects that are coming out of them are coming out of them. Very simple idea. But Ambatsumian, who was a very well-known theorist, always said you must look at the observations, and maybe if things are coming apart, appear to be coming apart, maybe they are coming apart. Conventional astronomers don't allow things to come apart. They always say there's enough dark matter in the system to hold it together.
I've come to the conclusion that what it is that will unseat an established prejudice, a strongly established prejudice, is one observation. One single observation, usually a very simple one.
The conclusion was very, very strong just from looking at this picture, that these objects had been ejected from the central galaxy and that they were initially at high redshift, and the redshift decayed as time went on. And therefore we were looking at a physics that was operating in the universe in which matter was born with low mass and with very high redshift, and as it matured and evolved into our present form, that we were seeing the birth and evolution of galaxies in the universe.
If proto-quasars ejected from the nucleus of active galaxies themselves evolve into new, younger galaxies, astrophysicists must find experimentally and observationally the mechanisms which describe this phenomena. One model explains that the proto-quasars are ejected, trapped in the galaxy's extreme magnetic field, aligned along the spiral arms, thus explaining the torn, disturbed features often observed in the galactic medium, and the frequent appearance of high redshift companion galaxies attached by filaments to a lower redshift parent galaxy. The The other, and most frequently observed alignment, is when quasars appear to have been directly ejected out of the galaxy's active nucleus along its line of least resistance, creating a field of systematically high to low redshift quasars, or younger to older evolved protogalaxies. This is exemplified in innumerable systems like the one around the galaxy quasar field of NGC 3516. If one disregards the proposed redshift distance to these objects, observation clearly points to ejection as a likely explanation for their close vicinity to the central galaxies around which they are found. These results, though preliminary, are promising developments which may lead the way to new and exciting insights in cosmology.
One of the best and earliest of the really controversial things was a Seafoot galaxy known as NGC 4319, which Chip Arp discovered that it has a protrusion coming out in the south direction from one of its spiral arms, and ending up on another galaxy known as Markarian, and people have tried to explain it away in all kinds of ways and tried to take false pictures to show that it's not there. But I've seen the good pictures, which were the first really good pictures were taken by Jack Sulentic.
NGC 4319 was part of some work that I did in the early 80s when I was a young astronomer, a young faculty member, and people were coming up to me and saying, oh, I've written a paper to show that what Chip Arp has done is wrong. There were at least 3 famous papers right around 79, 80, 81, and it took about 5 minutes to look at these papers to see that they were flawed. And one of them was a paper that claimed to show no connection between NGC 4319 and the quasar, Markarian 205. So at that time, I had the opportunity to work at JPL using the new image processing facilities that had been developed for the Voyager program, in fact. And it took 1 hour's effort to show that there was some kind of a luminous feature between those 2 objects. I don't know what it is, but there's no question that there is a luminous feature, and it cannot be dismissed in the ways that it was dismissed in the early 80s.
Suddenly there appeared press releases from Space Telescope Science Institute, which was the research arm of NASA's Hubble Space Telescope, and this press release said that they were not connected, and it gave a Hubble Space Telescope picture. It was not very deep, and you could just see 2 objects and no connection between them. And in this press release, then they said that this proved that there was no contradiction with the current expanding universe paradigm.
No connection between the 2 objects. So I looked at their picture, then I downloaded it, and it took me 5 minutes to show that it's still there. Now, I don't know what it is, but I think you face up to the existence of the feature and then you consider conventional and unconventional explanations. But I was really surprised that they felt it necessary to issue a press release saying, it's not there, it's not real. It's the same thing we saw 20 years ago.
But it's hard to get people to look at this because they don't understand it. You see, it's again the non-cosmological redshifts.
We realized that the people who had been processing the pictures and released it must have known that the bridge was there, and yet they chose to try to convince the public that in fact it wasn't there and that everything was right with the current expanding universe paradigm.
It's a strange attitude. I don't understand it as a scientist, really. I think that news release could have generated much more interest in astronomy than many of the more conventional news releases, because people would be talking amongst themselves, gee, what could that be? And then various people could offer scientific explanations. But to just sort of close the door in a way, you could argue that Chip, or someone like Chip, who believes in an alternate interpretation, I'm sitting in the middle of the bridge, so it could be either way. He should feel strong because I interpret that as a manifestation of fear and uncertainty. Because if I really had confidence in my paradigm, I'd put it right out there and say, well, yes, there is a bridge there, but it's either this explanation or it's that explanation, but certainly it's not what Shepard says. But instead to just say it isn't there, that's a manifestation of fear, I think.
This misrepresentation of the results on a public level, published through a press release from a government-supported institution, which was not refereed and which gave the wrong information, seemed to escalate, in my opinion and my colleagues' opinion, escalate the controversy into a publicity campaign, which was sort of like doing scientific research by press releases in an attempt to defend, as a sort of a last resort, a dying paradigm in physics.
I don't know what more one can do than the data are there, they've been got, we have to make sense of it.
I think in one sense they think it's bad to, quote, confuse, unquote, the public. Because if you believe in the standard paradigm with all your heart, you know it can't be real. I know it can't be real. You know, if I tried to be at all rational within the context of the current Big Bang ideology.
So if you have a cosmological theory that actually starts somewhere. I mean, I knew this when I was 10 years old, I think, sitting out in the backyard swinging with my brother, thinking about what would the edge of the universe look like if we got to the edge of the universe. And we both of us realized, even at that age, that the notion was somehow did not make sense. The universe can't have an edge, and it can't have a beginning, because if it had an edge, there'd have to be something on the other side, right? And if there had a beginning, there'd have to be something on the other side of that. And somehow cosmology, a satisfying philosophical cosmology to me, would have to start with that notion that it was always this way and it always will be this way. There's all kinds of things happening in there, but somehow the basic laws of nature are such that this exists.
Of course, this is astrophysics, this is science, and everything can be refuted. You have an explanation, you can produce an opposite explanation, so not everything is not so simple.
The theoreticians ought to be really looking at this theoretical problem, and the observers ought to be gathering much more data of the sort that we get. But I think they're all a little scared because it's an unpopular subject. They're worried about their jobs, and they're worried about moving on up the ladder, you know, if they're postdocs.
A young person in academia cannot afford to go against the Big Bang. He'd immediately lose his position. Tenure, yeah. He said last night. And so there is this difficulty. You can't expect him to do that.
Don't collaborate with Chip Arp, or don't collaborate with Geoffrey, because if you do that, you will have problems to get a position in such a place. I received such blackmails.
When I was a student, I was naive, and when I saw the chance to work with Chip Arp, he sent me a letter. This is 30 years ago, in fact. Good heavens, I hate to even think that it's 30 years ago. And warning me now that you may find some people put off by an association with me. And I didn't even understand what he was talking about. I thought, I'm just trying, we're just looking for the truth, aren't we? We're just investigating other areas, alternatives. But I found, indeed, that it was not this way, and that there was a great deal of hostility.
In my opinion, even if we are wrong, I'm not saying that we are right or anybody is right. From an observational point of view, we have a very peculiar object. So, and this peculiar object deserves some further research. This is what we need. And the interpretations are free and are to be discussed.
Now we're entering the realm of cosmology, and it is here that religion, philosophy, metaphysics, and science all meet. And make no mistake about it, they all play a role in our beliefs. The amount of data that we actually have to support any particular model is small. It's mostly consistency arguments. We can argue that the 3-degree microwave background radiation, yes, it can be explained within a Big Bang context, but I believe Fred Hoyle and Jan Harlacher and Jeff Burbidge have suggested an alternate explanation. And I'm sure we could find 10 more if the need were felt. But strangely enough, it's not. You don't get tenure in a university, you don't get promoted, you don't get recognition by looking too much into unpopular areas.
Cosmology is not a science. It has a lot of scientific aspects. We can know many things with the science. We can know how the galaxies are distributed, and this is all measured with the observations. We can know how rich are the metal, how many metals are in the intergalactic medium or in some galaxy, and all these aspects are scientific. But with regard to some considerations about the beginning of the universe, this is in some way crossing the barrier of the science and going to something in between the science and metaphysical speculation, in my opinion.
Sociology is very important in science. People are in groups and gangs and cliques and clusters, and of course that enforces conformity. You want to be one of the boys, one of the dare I say, one of the girls. It's the same after all. And so you tend to think alike. The longer you're together, the more you will think alike. I remember one famous group once, I asked them, how do you resolve disagreements amongst yourselves? And the reply was, we vote. And I thought, what a strange thing to do in science. Vote? I would think the best thing is that all 7 of you disagree. But there's a feeling that creates chaos. And the argument that we need some common thread or road to follow, for the majority to follow, in order to have some kind of organization to the whole scientific enterprise, there is an argument for that. But when it becomes all-encompassing, so that no other possibilities can even be explored, that is not good. And we're there.
Scientific notions take on, they have a lifetime that really is involved in it gets involved with like somebody's job. It gets involved with, my theories are all in this particular, support this area. And so I don't want anybody in my department, actually, who doesn't work in that. I wouldn't want somebody in my department who is working in a very different side of things, like the steady state Big Banger kind of thing. If you are a steady state person, at this point you're feeling a little bit paranoid anyhow, because most people said, hey, they found, Penzias and whoever he was, Arno Penzias, and the guy found there was the sky wasn't dark. There was a tiny little bit of light.
The cosmology as a science has begun 1 century ago with Einstein's theory. So in 100 years, you cannot produce a theory of everything. This is crazy. Even from a philosophical point of view, historical point of view, we have begun 100 years ago. In 1920, we thought that the Milky Way was all the universe. And now you want to produce the belief that in 80 years and something, you have produced the theory of all the universe from the beginning to now. This is somewhat incredible. Not very objective.
The Big Bang is predicated on the assumption that, from a point of view of physics, there are no surprises in store for us, which is very unlikely.
when you start using words like infinity and perpetual and steady state and all those kind of things, you're really using a vocabulary that was formed here in a quite limited sort of part of the vastness of everything, right? I mean, we developed that vocabulary as a way of finding food, mates, building shelters, that sort of stuff. We didn't develop that vocabulary from vast knowledge or need to know about how the universe works.
We're at the level of where the observations are clear, in my view, but the theory is not. And one of the things that you find in science, and particularly in astronomy, is that people find it very hard to believe in observations if they don't have a theory, ready to explain it.
And we also need theoreticians. Observations without any theory don't work. And theory without any observations certainly don't work. And the problem is to get them together. We need some glue.
To anybody with an open mind, that should really prove the case that quasars are associated with galaxies at ordinary kind of redshifts, while the quasars have higher redshifts. Therefore, they must part of the redshift must be non-cosmological, not to do with the expansion of the universe.
Because I'm always thinking, if we can only be more rigorous, they will believe us. But I was wrong. I was very naive. It's got nothing to do with that.
The rolling of the Big Bang, it's largely been determined by the way people seized upon these ideas, and there's been tremendous amount of propaganda making claims that here we see everything happening and this has to be right.
The people that are in that field treat it like a religion.
And not very objective.
The reaction of the Orthodox astronomers to this idea is that it violates the Big Bang assumption, the Big Bang hypothesis, and therefore it cannot be true.
The amateurs tend to be more broad-minded than the people who have to earn their keep by being narrow-minded. I got it.
Was this worked out by somebody, or was it, did it just happen by chance? Which is really the same thing as saying, did the universe happen by chance? And I have to say, when I look at it, it doesn't look to me at all like chance.